Welcome to this data engineering crash course created by Justin Chau. This course covers the essentials of data engineering. You'll learn about databases, Docker, and analytical engineering. You'll explore advanced topics like data pipeline building with Airflow, and you'll engage in batch processing with Spark and streaming data with Kafka. The course culminates in a comprehensive project, putting your skills to the test and creating a full end-to-end pipeline.
Hey everyone, welcome to the course. My name is Justin Chau. I'm a developer advocate at Airbyte. I'm going to be going through kind of essentially what you need to know in order to become a data engineer, what goes into data engineering, and then this is going to go into a fully fledged demo where you can follow me in creating a data pipeline from scratch and then evolving that into a fully fledged data pipeline using open source tools such as Airbyte. So hopefully you enjoyed this and this gathers some interest. If anything along with data engineering or software engineering in general is of interest to you, then this should be good to know. But without further ado, let's get into the course. So we're looking over the introduction to data engineering, but you may be thinking, why data engineering in the first place? Well, there's a couple of reasons why you may want to consider getting into data engineering. First, there's a high failure rate of big data projects, and the percentage there based off of the data that we've collected is 85 to 87% of those projects failing. And obviously, as I've said, that's pretty high. Those failures are due to unreliable data infrastructures and quality data. In the past, there's been an expectations for data scientists to build out that data infrastructure that's necessary for those projects. With the infrastructure that was put in place, there's always incorrect data modeling and redundant work that they have to do. Because of the incorrect data modeling and the redundant work that they have to do, there's a high rate of data scientist turnover. So there's a high need of data engineers to process that data and extract value instead of the data scientists. With all of that being said, there is a growing importance of the data engineering role as we speak. If we're talking compensation, right now in the US, the average median salary for data engineers is 90 to 150K a year. And obviously, I say in the US, it still highly depends on the location and whether you're in the States or not. So that number will change. Now let's look at the business potential and impact that data engineers can have in any company. You will have a crucial role in the success of making data-driven decisions in the AI and ML space for applications, especially with the rise of ChatGPT right now and the AI space in general. Data engineers are going to have that crucial role in determining what happens with those applications and the data in general. Now let's look at the business potential that you have as data engineers and the impact you can make in any company that you work for. The first one being is that you're going to have a crucial role in the success of making data-driven decisions in the AI and ML space for applications. And so with the rise of ChatGPT and the AI space, you're going to be a crucial factor in that aspect and for any company that wants to and should be getting into AI in general. The next thing you're going to be doing is ensuring that there's efficient management and processing of the actual data as it moves downstream. While it moves downstream, you're also ensuring that the data quality, the security, and availability of it to those teams downstream, such as the data scientists, the data analysts, or any other team that has to work with data in your company, that it's quality, it's secure, it's formatted the way that they need it, and it's never not flowing downstream. This will also lead to better insights and outcomes for your company and overall just drive innovation and competitiveness so that your company can thrive and that your team can thrive. So now we're moving on into the first module, which is the introduction to Docker and what we use Docker for in data engineering. But first, we have to have a better understanding of what it is if you haven't used it before. Docker is an open source platform that simplifies the process of building, shipping, and running any applications inside containers. So imagine you are working on a project and you want your coworkers to try and use it to see if there's any issues, but they can't run it for some reason. And you kind of run into that good old saying of, hey, it runs okay on my machine. Well, what Docker is able to do is you're able to put your environment into a container, and that container will include every dependency and kind of silo everything into, again, this container, which you can then pass on to your coworkers or even run up in the cloud to have your application running as it was when you were developing it. So it essentially just helps organize and make sure everything works as developed. So if we're going over containers and their benefits, containers are lightweight, portable, and self-sufficient environments that package an application along with all its dependencies, libraries, and configurations, as I mentioned before. Again, just going over over how much Docker has really helped engineers in general on packaging their applications to make sure that they don't run into any issues down the line when testing and developing, and to make sure that those environments are reproducible in case anything goes wrong, and making sure that also when they're pushing up into the cloud or into production, that those applications are working as intended, and when they were testing, it's going to work the same way in prod. So now just imagine that all your app's code and all your app's dependencies are landing into one of these containers, and you're shipping one of those off out into, your coworker's place or on AWS or GCP. Everything that was inside that container will be seen on the other end as well. Now, as I mentioned before, in software development, we're looking at Docker in the form of testing, deployment for its ease of use, speed, and flexibility. It assists with the deployment, scaling, and management of those applications using what we call containerization, which is just a lightweight form of virtualization. So if you look on the right-hand side's illustration here, you can see that we have a couple apps that are in containers using Docker, as well as, sitting on top of your operating system and the infrastructure, and it's all running all within the Docker ecosystem. Now, there are three main concepts with Docker that we need to understand. The first one is going to be Docker files. The second one is going to be Docker images. And the third one is going to be Docker containers. Now, let's go over what those three are right now. The first step is the Docker file. The Docker file is a text file that consists of all the instructions needed, hence blueprints, that we want Docker to use, all in order to create the Docker image. So the Docker image is what is created from the Docker file, hence the blueprint. So the blueprint then creates our Docker image, which is the lightweight standalone executable package that includes everything we need to run your piece of software. That includes code, the runtime, libraries, environment variables, and config files. The one thing to note is that images are read-only and immutable, so nothing can change within the Docker image itself. If you wanted to create another Docker image or modify anything that exists, you want to modify your Docker file and the instructions that are inside that text file to create a new Docker image. So that's why we stick the image into a Docker container, which is the runtime instance of our Docker image, or in other words, the running version of the image is the Docker container. This Docker container is completely isolated from the host and other containers that you may have running. It has its own file system and can be started, stopped, and deleted independently. So for example, we may have one Docker image that contains our application, but we have three different Docker containers running that same image. So we have three different environments, three different instances of that image, but I can stop one and the other two are still going to run. I can delete one and nothing changes in those other containers because they are isolated environments, and you can run tests. You can do anything you want in those containers, but nothing will change unless it is done inside the container. So first things first, to get started with Docker is obviously we're going to want to install Docker. So head over to docker.com, and here is the landing page of Docker. Now, what we want to do is simply just download Docker for whatever operating system you have. I am currently running on a Mac Apple chip, so I would click this and download Docker Desktop, which also comes with Docker Compose, which we will also need for later along in this course. But just know that Docker Compose and Docker Desktop are two prerequisites to running with Docker right now. Now, if you're on Windows, obviously follow the instructions for Windows. If you're on Linux, follow the instructions for Linux. But go ahead and download Docker for your machine. And if you have any questions, you can also go over to Docker, and they have a really good explanation in their docs on how to install Docker Desktop for your machine and get going with that. So make sure you do this first. Now that we have Docker installed, I think the Docker docs have a great getting started guide on how you can actually containerize an application. And so what we're going to do is actually just go through this really quickly, and it can give us a great idea of how to containerize an application through a Docker file, how we build the image, getting the image to run inside of a container, and then a couple other things like networking and things like that. So let's go ahead and go through the getting started guide, and then we'll move on into the SQL module right after. So if you were still confused on what a container is or what an image is, it gives you a good rundown here at the beginning of part 1. But let's go into part 2 on how we can containerize an application. First things first is they actually have a getting started app, which is just a to-do app for you to containerize. But what we're going to do first is simply just clone this and use it for the rest of this guide. I'm going to open up my terminal here and make a directory, and I'm going to call this Docker tutorial. And I'm going to cd into Docker tutorial. And then after that, what we're going to do is paste in the command that was in there, which simply just clones the repo. And obviously, if it wasn't clear enough, and make sure you have a text editor installed. I'm using VS Code, and I think that should be it. Obviously, Docker installed. Now that it's cloned, let's go ahead and CD into the getting started guide. And what we can see here is if we open up VS Code, there's a couple things here. So we have a spec file. We only really need to look at the source file, but this is just a simple to-do app. So let's go ahead and go back to the getting started guide. And it has the instructions for you on Mac and Windows. So depending on your operating system, make sure you follow the right ones. But we've already CD'd into it. What we're going to do is inside of the root directory of the getting started app, we're going to create a Docker file. And as mentioned before, this is going to be the instructions on how we build the image that containerizes the application that the Docker file is sitting in. So now that I've created the Docker file, if I type in ls, you can see that the Docker file is there. So what we're going to do is they've provided us the instructions or the contents that we're going to use for this Docker file. Now you can see that we have a couple things here that we haven't seen before, but essentially what from is we're going to use the node 18 package that we're pulling from the Docker Hub to run our environment in, or our runtime. The working directory is going to be in the /app or the root directory of the application. This simply copies everything, and then we're going to run this command, which is yarn install production. Other commands that are going to be node, and we're going to look at in the source index.js file, and we're also exposing port 3000. So you can see that these instructions are pretty straightforward, read like English. The one thing to take in mind is that this does have to be in order. This cannot be misplaced. So keep that in mind when you're writing your own Docker files. But what we're going to do is we're simply just going to copy this, switch back over to our VS Code, head into Docker file, and then just paste this in and save. Now that that's saved, they give us a command. So we're going to run docker build -t, which simply just tags our image. And then we're going to name it getting started. So that will be the name of our image. And then the dot we need at the end to tell Docker where to look for everything to containerize, which will simply just be in the current directory. So I'm going to go ahead and copy this command as well, paste this in. Also make sure that you have the Docker daemon running. If you install Docker Desktop, just simply open the application, let everything launch, and then you should be good. So I'm going to go ahead and hit enter. This is going to do a couple things. Awesome. So now if we go back into Docker Desktop and we go into images, you can see at the very top, getting started is created. We have an image. The tag is going to be the latest tag, hasn't been used yet, tells us our size, but now we have an image with everything, as you can see from the Docker file. So you can see the commands that we ran. We have node version 18, which we did with the from command, and then we're also exposing port 3000. So you can see that the Docker file's blueprint is in play here. Next thing we're going to do is going to start this container. So we can say docker run, which is going to run the image in a container. We're going to flag it for DP, which the D flag is short for detach, which runs the container in the background. The P flag is short for publish, which means that we're creating this port mapping so that we can actually access this container locally. And with the mapping, we're pointing it to a local host here. So 12.0.0.1, and we're opening it on port 3000. Now, keep in mind, this can change. Say you have an application already running on port 3000, but you wanted to run this on port 6000. You can definitely change this, but this number after the colon needs to stay at 3000 because in our Docker file, we exposed port 3000. So to be able to access this, we need to still keep that number to 3000. And then after this, this is the name of our container. So obviously we're going to name it getting started. So let me copy and paste this, go back in our terminal. And as you can see, it spits out a container ID. I'm going to go ahead and copy this for later. But if we go back into Docker Desktop now, just for a simpler GUI to see, if we go to the containers tab, you can see that a container was created with the image getting started, and it is currently running on port 3000. So now, if we're going to go back here and we want to go to localhost port 3000, you can see that the app is now running locally and we're accessing this container. So that is good. Now we can move on. Well, first of all, what we may want to do is I can show you guys that you can actually write stuff to this. So as I mentioned before, this is a to-do app. So I can say get cat food, take out the trash. Very simple React app going on right now that is inside of a container. So as I mentioned previously, before we started this demo, is that Docker contains a runtime, it contains all the environment variables, and it contains every single dependency that React or this application in general needs in order to run. And so we're siloed inside of a container with a runtime, with this environment, and we're able to actually use the application within the container. There's a couple other commands it tells us. So in the command line, we can run docker ps, and it will name any other containers that are currently running along with their container ID. So as I mentioned, this container ID popped up, but if I type in docker ps, it's going to be the only one running. But if there were any other containers running, we can pull their container ID along with their names and other information. The other thing to note too is that container IDs can be accessed. You don't need the full container ID. You only need the first couple digits here, and you can still access that container. So let's move on to part 3 here. Now we're going to want to make some changes to this code, and this is going to show us how updating the application itself changes things. So they want us to change a paragraph inside of the src static js app.js file. So let's head back into VS Code. We're in src, we're in static. We're gonna go to index.js, js app.js, sorry, and then go to 56. And then we're simply gonna change this text to be what they told us. We're gonna go ahead and save that. But now that we've updated the application, that means we actually have to build another version of this image, because the image we built cannot be rewritten. It is completely read-only. And so if we're gonna make any changes, we have to create another image. And so that's exactly what we're going to do. We're gonna run the same docker build command in the terminal, and that's going to build another image. And so now what we're going to do is we're going to run container command, but we're going to get an error here because we already have a container with that name that's binded to port 3000. Now, if we want to remove the old container, this will bring us back into docker ps. So we're going to run docker ps. And so we can see that this container is still running. So what we're going to do is we're going to say docker rm, paste the container ID, and that should give me another error saying you cannot remove a running container. So we're gonna say docker rm and put in the F flag that will stop the container as well as remove the container. So I'm gonna do that, and that should now get rid of it. And now we can see that this has stopped, and we can copy and paste this again. And now we've created another container, and it has started running with the updated image. Now, if we go back into the to-do app and refresh this, you can see that it's completely fresh and the new text has been added. So that's what happens when you go and update an application. We're gonna skip part 4, but if you wanted to push this image up into the Docker Hub for other people to access, you can absolutely do that. We're not doing that right now. So at your own, you can go through part 4, but we're going to go to part 5. And this is actually a big one because sometimes we're messing with data. And as we saw in the to-do app, we have data and we want to persist it. But if we were to stop the container and open it, the data that we had previously is going to be gone. So the way we can actually persist data is by simply adding a couple things. So we're going to go through the steps one more time, but we're going to run this command here. We're simply going to start a container that has Ubuntu running, and it's going to contain a file called data.txt that will have a random number between 1 and 10,000. So let's go open up my terminal, and we're going to run docker through that. And as you can see, it created another container, has an image of Ubuntu. I already had it installed locally, but if you do not have the Ubuntu image, it will immediately detect that and download that from the Docker Hub. Once we have that going, we're going to copy and paste this, and this will simply check the file that is inside the container, which is data.txt, and it should spit out the name of or not spit out the name, but it should spit out the number. And what we need to do is we need to remove the current container ID, or the placeholder there with the actual container ID. And there we go, we have 848 that spit out to us, so we know that there is data inside. They want us to start another container that has Ubuntu, so we're gonna go ahead and do that as well. And it'll list in every single folder that is currently in the root of that container. And then what we're going to do also is we're going to remove that first container. So again, we're gonna go docker rm/f, and then the first container should be this one right here. So we went ahead and removed that. So the way to persist data in that container is going to be by creating a volume, and it's pretty simple to do. So the first thing we're going to do is run this command right here that they give us. Essentially, we're going to be creating a volume called to-do-db. So let me go ahead and open my terminal here. And what we're going to see in the volumes tab now is a to-do-db. what we're gonna have to do is remove the container that we created because it is running without a persistent volume, because we created the volume after container creation. So we're gonna have to create a fresh one. So again, let me grab the container ID of the getting started container, and same thing, docker rm-f, and with the container ID, and that should remove it. For other purposes, let me also just remove this as well. Cool, so we have a clean slate. Now we're simply going to copy this command, but there's a couple things here. So along with the run and run command, the DNP flags, as well as mounting this, or not mounting this, but binding it to the port 3000. We're also mounting the volume here, which is going to be the flag here that we see, or the option. And we're specifying the volume that we want to mount. So the type is going to be volume. The source of the volume is going to be the to-do-db volume we just created. And the target is going to be where the actual data sits inside of the container. So that is the path that we're going to do. And then getting started, we're actually just specifying the image that we're using, or the container. So let me go ahead and copy this command, paste it in, and now you can see that we have another container with getting started, and it will be utilizing the to-do-db volume that we've created. So now what we can do, since it's running, we're gonna go back here to the to-do app, and as you can see, I have some data that was in there and I didn't add anything. You saw that it was empty, and there's 2 tasks in here that I added previously yesterday, and they persisted. So now we're able to tap into the volume and the data, and anything that we do from here on out, let's just say, I don't know, go to the gym. We want to add that. If we stop this container and then start it again and refresh this, we can see that the data is persisting now. So volume creation is going to be the way to persist databases, especially if you're testing stuff. This is a good way to do that within Docker. And it's easy to play around with servers and actual databases now that we have data that persists, instead of having to reload and add more data over and over and over again. So there's a couple other things that we can see, but if you were to run Docker volume inspect on the volume itself, you can see a couple of things of metadata here, but specifically we get to see the mount point, the name, the scope of it, and its created time. So those are a cool couple things if you want to persist databases within Docker. Next thing we're gonna do is we're gonna skip over to part 7. I don't really want to touch into the use bind mounts right now, but multi-container apps. So as I mentioned, we may have a couple of things that we're running, and so multiple containers are going to be needed. In this case, we have our to-do app, but we also want to create a MySQL container that runs in tandem with the to-do app so that we can isolate our database and our front-end app here. In order for these 2 containers to talk, we're going to need to create a network, and that's exactly what we're going to do right now. So we're going to run this command, docker network create, and the network's name is going to be to-do app. So let me go ahead and run that right now. It's going to give me an error because I already created this, but go ahead and run that and it will create a network there for you. So now what we're doing is we're going to create another container and then attach it to the network that we just created. And so you can see that we have a couple flags here. First ones are going to be the network. So we're tying the network of this container to the to-do app network we created. The alias of this is going to be MySQL. So when we see the container through the network, we're going to know that this container here is the MySQL container. Some of the variables that we have here are going to be the volume that we want to create is going to be the to-do MySQL -data volume. So we're creating a volume there to persist the actual database. And then we have 2 environment flags specific to MySQL. Again, if you're using something like maybe say Postgres, there's going to be some different environment variables you need to attach to this container. 2 of the first ones being in MySQL are going to be the root password as well as the database name. So we know that our password here is secret, and then the name of our database is going to be to-dos, and we're going to be pulling the MySQL version 8 Docker image. So what we're going to do is copy this over, and we're going to go into our terminal and create that. And now we can see we have a MySQL image. Again, I've downloaded locally already, and the container is now running. To confirm that we have the database running, we're going to run this command here. So we're execing -it, and the container ID will go right after that. Then it will spit out the MySQL command, enter in the user, which is root, and then ask us for the password. So let me go ahead and copy this really quick in here and copy the container ID that it gave us, and now replace the placeholder. Enter, it'll ask us for the password, and as we saw before, it was secret. So let me enter that in, and now we are inside of our MySQL database. The next thing it asks us to do is type in show databases to confirm that our databases was created, and we see the to-dos database is here. So our commands ran successfully. Now we can say exit, and now we have a to-dos database. We're going to skip this part because it's not really necessary, but if you want to follow it, it simply just spins up a DNS tool that will allow you to see the IP address of the container and show you that each container has its own IP address. So this networking step really is crucial for these two containers to talk to each other. So what I'm going to do here is I'm actually going to first remove the container of the getting started app that we created first because it's not tied to this network yet. So let me go ahead and remove it first. And then we're going to create another one using this command here. And as you can see, we're doing the same run command here, but with a couple other flags. So there's just, we're tying it to the network here. There's a couple other environments like hooking it up to the MySQL database so that we're actually able to push data to the database. Same thing with the node versions, and then initializing the application with yarn install and run dev. So let me go ahead and copy and paste this over, and there we go. We should have another container built with the Node 18 Alpine image instead. Now, if we want to connect to the MySQL database, let's go ahead and do that here. So we're going to copy this command again, copy and paste this, and then we need to get into the MySQL database. So let me copy and paste that. Enter the password here, and it is secret. So now that we're in, so we're going to do the select function here, and we're going to select all from to-do underscore items. And we can see that the 3 items that we created inside of the application are now here inside of the database. So we're confirming that the data that we created in the volume is now inside of our MySQL database. And that right there is the power of networking. Earlier in this module, I also mentioned Docker Compose, and it makes this whole process that we just did with this application 10 times easier. Again, as I mentioned before also, is that Docker Compose is a tool that helps you define and share multiple container applications. And so we're going to be doing that right now. This right here was the old command that we had to run inside of our terminal to get everything running for the MySQL and to-do app. But we can simply do that, all of this in one Docker file. And the Docker file now changes to a Docker compose.yaml file, or you can shorten it to compose.yaml. So we're going to head back into our terminal here, and inside of the root where we initially put our Docker file, we're going to create a new file and call it compose.yaml. And what Docker has provided us with were a couple things. So we're going to go ahead and copy and paste this. Now make sure it added to space here, but it will error out if it has an empty space. So cover that space. Again, YAML is very strict with spacing and indentation, so keep that in mind. But the first thing here we're going to do is specify services of our compose file. The first one is going to be our app, which is going to contain the image of the node version 18. So we're going to run node in this container. Next thing we're going to do is add the command. So the command we want to run is going to be the yarn install and run the dev environment there. So we're going to add that here. Next thing is we're going to open up the ports, and it's going to be the same port, the 127 on port 3000. So now we're moving the working directory to the volume mapping. And by doing that, we're going to add the working directory and then the volumes. So let me go ahead and add that as well. And then finally, we're going to add the environments. So these environment variables are all going to be the MySQL environment variables so that we can access the database through the application itself when we add any to-dos. So again, the host, the user, password, database name, these are all there and are going to be specified for this app container. Now we're going to do the same, but for MySQL. So we saw the app container, but now if we back up a couple spaces, we're going to add the MySQL container. So you can see that these two are on the same line, one being app with all of its information here, and then MySQL will contain the same. But now we're pulling the MySQL version 8 image. The volumes that we want to use for this container is going to be the to-do MySQL data. So let me go ahead and add that. And then the overall volumes here are going to be outside of that. And then finally, what we need to do is we're going to add the environment variables for this specific container so we can access it. Now, everything in your compose.yaml file should look like this. Again, the top level is identifying what services that we want this file to create. The first one being our app container using the Node 18 image. This is the command we want to run. This is the port that we want to expose and use to access this application. Our working directory is going to be this root directory that contains everything here. The volumes we're mapping is going to use the app. This is the environment variables we use to connect to our MySQL container that also contains its own information. And so now it's much easier with Docker Compose to run this application. Now that we have our compose.yaml file, I can open up my terminal here. Let me exit MySQL, clear this. Now all I have to do is run Docker Compose up, and I can add the -d flag to make sure that this runs in the background. And what that did just now was literally spit out 2 containers. One, it looks like it failed because I have a container running already that has 43,000. So let me go ahead and just delete this and delete this from the Docker desktop app so we can have a clean slate. And let me run the same thing. And there we go. Now it's spit out the getting started app, and it contains our app and our MySQL container, both of them running, and we have opened on port 3000. And if I head over into our localhost port 3000, I'm refreshing and you can see it's all fresh. So we're using a different volume here, but the application is now running successfully. It is attached to our MySQL database, and we can continue and now add data here that will persist because we have tied a volume here to both of these containers. Now, if we wanted to tear it down, all we would have to do is Docker Compose down, and that will shut down and stop our containers from running. And that right there is a simple rundown of how you can create images and a container through Docker using Docker files or a compose.yaml file, and then accessing those containers to do certain things. We ran a application in the form of a to-do app, and we also created a MySQL database pretty quickly here in their own environments. And that way we have coworkers that are working on the same thing. They can run the same image that we're on using the same environment variables, using the same dependencies, and essentially be able to recreate any problems or just have the same environment that we're running on every single time. And that is the power of containerization through Docker. We're going to be using a lot of these skills in the coming lessons, so hopefully that helps. But now let's move on to the SQL module, where we're going to be using SQL, but we're also going to start our own little database inside Docker as well. So let's get to it. So now that we have Docker set up and we know the basics, we're going to move it on to SQL or SQL, however else you want to call it. But SQL stands for Structured Query Language. It's a standard language used for database creation and manipulation. Databases like MySQL or Postgres use SQL for you to query any of the data within their own tables. So let's go ahead and start our playground. We're going to set up a database using Postgres within a Docker container, and then we can create our own tables with fake data to play around with, and we'll use them later on in the course as well. All right, so first things first is I have a terminal open and I've created a data engineering database directory. Because we're using Docker, we do not have to install Postgres locally. What we can do is run the command docker pull Postgres. And what that's going to do is look up the image of Postgres on the Docker Hub, pull the latest version of that down, and now we can actually create a container that's running the Postgres image. So now we got to start our Postgres container now that we have the image. So I'm going to say docker run. The name of this container is going to be data engineering Postgres. The environment variables that I want are going to be related to Postgres, which is going to be Postgres _ password. And what that's going to be is just going to be secret. And then I'm going to do the D flag, and we're going to say we're going to use the Postgres image. Go ahead and run that. Now I have my container. Now what I want to do is I want to create a new database inside of Postgres. So I'm going to say docker exec -u for the user, which is just Postgres as default. The name of the container, which is just data engineering of Postgres. I'm going to say create DB, and the name of the database is going to be Postgres DB. Now that we've run that, we've created a sample database inside. Now let's go ahead and connect to it. So I'm going to say docker exec /it data engineering Postgres psql -u for the user on Postgres, and the name of the database, which is going to be Postgres DB. Now we are inside, as you can see, of the Postgres database. If I do /dt, no current tables as of right now, so that's exactly what we're going to do. We're going to create our first table. I have these commands already written out so I don't waste as much time. So the first thing I'm going to do, just for an example, is create a table called users. So inside this command, you see a couple things. So we have an ID of the type serial, which is also our primary key here as an identifier. We have a first name, which is at most 50 characters. We have a last name, which is the same thing. We have an email that is also characters, but we want it to at least be 100. And then we have a date of birth, which is just in the type of date. So we're gonna hit enter. It's gonna show us that we have a table. So now if I do /dt, we can see that the users table is now created and populated inside of this database. I'm gonna go ahead and copy in some fake data as well. And don't worry, these will all be in the description below. So that way you can copy and paste this in as you follow along. So I'm gonna copy and paste this, and this is simply just users. So it contains a first name, a last name, an email, and date of birth. So let me go ahead and enter, and you can see it entered in 14 records. So now this brings us into the first command we're going to learn. So the first command we're going to want to learn is the select command, and it's pretty self-explanatory. As you saw already, we entered in 14 rows of data, and if I wanted to select anything from that table, I'm gonna need to use the select command. So I'm going to say select, and I'm gonna add this asterisk. What the asterisk typically means is a wildcard, pretty much meaning you want all of the columns within a table. So you can read this query as select all. Now I'm going to add from, and then the last part of this is going to be the table name. So I'm going to say users, and do not forget, this is very important, that every query needs to end in a semicolon. Otherwise the query won't go through. So make sure you always add a semicolon at the end of every query. So once I hit enter, you're going to see that I get back a formatted view of the table that I just queried. We saw before that we entered in 14 rows of data, and I see that I get exactly 14 rows back, all having the ID, first name, last name, email, and date of birth formatted in a much more pleasing way than what we see up here. The select query is going to be a frequently used command by everybody who uses SQL, so make sure you know it and understand it, but again, very straightforward. Another command that gets used in conjunction with select is also going to be distinct. We use distinct in conjunction with select if we want a specified value within a very particular column. So let's say we want every single email within the users table. What we'll say is we're going to say select distinct email from, and then we're going to say users table. So again, we're reading this back. If you haven't noticed already, typically all the SQL commands are going to be in all caps. Keep in mind, you do not need this, but it is much easier, and it is probably best practice to capitalize every command that is SQL and lowercase everything that is either a table or some type of value that you need. But if we're reading this back, we want to select distinct emails from the users table. So again, it reads just like English. We add the semicolon. If we hit enter, it's going to give us just the emails in every single distinct email. Now keep in mind, this is not in order, but we do get 14 rows of data back. We can see that the query was successful. So that's how you can select data from the whole table to get a better view, or select distinct values within a particular column. But let's move on to other commands. So now that we have our users table that has data that exists in there, what if we wanted to update some information, say an email if a user changed their email, or a date of birth if they entered it wrong? This is where the update command comes in handy. So let's say, for example, if we go back up to our table, that we wanted to change John's email. So what we're going to do is we're going to say update. So the query starts with update now. After update, we're going to enter in the table name. So we're going to say users, and then we're going to say set. So now we want to address what column and value we want to change in the users table. So we're going to say email, and then that's going to equal whatever our value is going to be inside of single quotes. So for example, we can just say, new _ email @gmail.com. The problem with this query is if we were to hit enter on this, it would change the emails for every single row inside of the users table, which isn't exactly what we want. And if you were doing this in a production database, it would probably go haywire. So how can we modify this query for it to actually only update one person's email inside the table? What we can do is introduce the where command. So after we set the email to the new value, we're going to say where, and then we're going to say first _ name. So now we're saying where the first name, so we're selecting a particular first name, is equals to, and the first name in this case is going to be John, and we're going to hit a semicolon. So again, we're going to backtrack here. We're going to update the users table. We're going to set the email. So we're selecting the column email. to new_email@gmail.com, where the first name is equals to John. So that means that we're gonna look for John inside of the first name column. Once we find John, we're gonna go to his email and change the email over to the new value. So if I hit enter, we can see that we have one updated change. Now, if I say select, go back to the cap, select all from users table, we're gonna see that John actually changed, so he gets moved down. He still has an ID of 1, but his email is now new_email@gmail.com. So again, if we're using the update command, it's very helpful if anything changes in terms of data and we need to update something, that's where we'd use the update command. Now let's say you wanted to enter in new data into a table. Well, that's where the insert command comes in. If you're starting to see the pattern here, SQL commands are very self-explanatory in the fact that they read English and kind of like Python. So if you wanted to insert new values, you would reach for the insert command. So we're gonna create a new table called the films table, add some films, and then show the insert command, but go more in depth into it. All right, so we are back in our database and I have the command here already. I'm going to create the table of films. Again, so create table is also a command that we didn't get really into, but again, self-explanatory. We're just creating a table here called films. Within the parentheses, we're going to see the film ID with the type. We have a title, a release date, a price, which is new that we're seeing a decimal type. We have a rating and then a user rating. The one thing to note within the user rating is that we're checking to see if the number value that goes into user rating is greater than or equals to 1 and that the user rating is less than or equals to 5. So obviously we want to go between 1 and 5 here. So if I hit enter, we're going to see that if I do /dt, which is like ls in a normal bash terminal, is kind of like listing every table inside of a database. We see that the films table is now created. So let me go ahead and copy my insert command here. And we see that we have insert into. So again, self-explanatory, we want to insert values into the films table. Within the first set of parentheses, we see the names of the columns that we want to add. And again, those are fitting and matching exactly what we have on this side right here when we created the table. After the first set of parentheses, we have a values command. And after that, everything inside of the parentheses are values that have to match the order in which you placed every single column. So the first one we have is the title, which is, these are all not fake data, but I have them generated. So we have inception, the release date, which is right here in the date format. We have its price in the decimal format. We have the rating of the movie as well as the user rating of the movie. And so you can see it fits within this set of parentheses, it fits the order of this set of parentheses. So if we hit enter right now, you can see that we've entered in 20 rows of data. If I say select all from films, we can see that's a little out of place here because my terminal is a little big, but we can scroll down and we can see that all the data was entered in. Go ahead and skip this line. Let me make it smaller so that we can see more of it. But if I hit that again, we can see the table is formatted properly, the same way that the user's table was. But that right there is how you can insert data into a table. It doesn't have to be that big every single time. If we just wanted to insert one more row, it would just be the exact query back here, except just one more line. Another really useful command that you should know is going to be the limit command. Imagine you have a database that has thousands upon thousands of records, but you only need a certain amount, so you want to limit the query to that amount. That's where limit comes in. So as we saw in the new films table, we saw that we have 20 rows, but what if we only want less than 20? So let's say 5. That's where we would use limit. So let's do select all from, we're gonna go into the films table, but after films, typically we would have that semicolon to end the query, but now we're gonna add limit and then the value of what we want to limit the query to. So because we have 20, we want less than 20 here. Let's just say I only want 5 records to come back. If I hit enter, you're gonna see that I only get the first 5 records in the table to come back. So That is a very easy to understand command here and very useful to limit the amount of records that come back, because you could imagine, as I said before, if you're trying to query a database or a table that has thousands of records, that query could take a very long time. So if you want that to speed up a little bit and you only need a certain amount to see what the data looks like, if it's formatted properly, the limit command is going to be your best friend. The next thing we're going to cover is going to include some math here, but we're going to go over aggregate functions in SQL. Aggregate functions in SQL allow us to do computations on top of a single column through every single row of a table. It's incredibly useful in data analytics, where it allows us to calculate important metrics and gain insights from our data. So let's get into the first one. The first one is going to be count. Now, the count function allows us to count the number of rows depending on if it matches the condition that we give it. So now that we have our films table, let's say we wanted to count the amount of films if we don't know how many are inside the table. Let's start the query here. So let's say select. Right after the select statement, we would say count. In the parentheses, we would count however many we want. But if I add an asterisk here, that's going to say count every single record inside of this table if it matches the condition I'm about to give it. So we're going to say count from films table. So again, this is selecting the number of records within this condition here, and what we give it is an asterisk for all from the films. And what this should give me back is the number 20, because we have 20 rows inside this column. So just remember, within this parentheses here is going to be the condition. Depending on what that condition is, it will spit back to you always a number depending on if it's true within that condition. And count is really useful for that. The next aggregate function we're going to look at is going to be the sum function. Now we would use sum to calculate the sum of all the numbers in a numeric column. So if we take a look here, we have a prices column. So now if we wanted to, let's say, calculate the sum of every single price in this column, we would say select sum. Inside the parentheses, we would say price, because we want to use the price column from the films table. So now if we look back at this, we're selecting the sum function is going to look into the price column and add up every single number value within it, and it will spit back to us the total sum of every single movie that we have inside this table. So if you were to have gone to every single one of these movies at this price, you would have spent $228.80. Now let's say we want to get the average of something inside of our table. Say, for example, we want the average user rating of movies in this table. Well, that's where the average statement or the average function comes in. It's going to look the exact same as the sum function. So we're going to say select, but instead of sum, we're going to say average or AVG. And inside the parentheses, we're going to enter in the column that we want to take a look at, which is going to be user underscore rating. Close the parentheses there. And then we're going to say from the films table. And that then gives us an average of every single user rating that the movies have, which is going to be 4.6. And lastly, one of the more useful ones is going to be max and min. Max and min are used to find the highest and lowest numeric value within a column. So let's look at our price column again. If we wanted to get the lowest and the highest values in the prices column, our query would look something like select, and then we would say max. Inside the max column, our condition would be the column we want. So we want price. We're going to add a comma here, and we're going to say min, again, parentheses, and looking at the prices column from the films table. Now, if I hit enter here, we're going to see the max value here was $14.99 and the minimum was $7.99. So the cheapest movie out here that was in the table was $7.99 and the max was $14.99. So very helpful to sift through a big table if you're just trying to find the highest value and the lowest value. Another useful statement in SQL is going to be group by. We use group by to get identical data into groups. It's also typically used with aggregate functions like the ones we just did, like count, sum, min, max, average, so that we can group the result sets into one or more columns. Let's take a look at how this would look if we were to use group by with the average aggregate function. Let's take a look at the films table again, and let's say we want to group the average user rating based off of the movie's actual rating. How would we do that? We're going to select the rating column here, and then we're going to add a comma and add our aggregate function since we're stringing together two selects. And inside the condition of the average function, we're going to put in the user underscore rating column from the films table. After that, we're going to say group by, and what we wanted to group that by is by the rating. So we're going to get the average of every user rating inside of the film's table and then group the results by each individual rating. So we have PG-13, we have R, and we have G and PG. So we should see 4 rows inside of the results. After I hit enter, you can see the average rating for R-rated movies was 4.61. The average rating for PG-13 is 4.5. PG was 4.8 and G was 4.4. And now you can see how this could be useful to group together identical forms of data and compare them against each other. This is especially important in data analysis. Again, it allows us to organize the data into a different way and then run computation on top of that, especially with them being in groups. It's also important to note the order that we did this query. If we were to have switched the rating and the average functions here, we would have got a different result. So the order of the query does matter depending on how you want to format your data. So keep that in mind. One cool feature you can do in SQL is join 2 different tables that have different data sets and get a result that combines both of the data you need into a formatted table. There are 2 different commands that we can use for this, and we're gonna go over those right now. The first one being inner join and the left one being left join. They do very similar things, but there are key differences that make them unique. So let's go over what those are right now. But before we do that, we're gonna need to create another table that we can use data against alongside our existing films table. So let's first create the film category table. So I'm gonna go ahead and copy and paste this. So we have a category ID, a film ID, and the category name. These categories match every single movie that we currently have inside of the films table. Now I'm going to go ahead and insert our values here. So let me go ahead and do that. Hit enter. We have 39 records here. So now if I do select all from the film underscore category table, now we can see that we have our category IDs and we have our film IDs as well as their category names. I'll go ahead and skip all these lines here. So now we have 2 tables that we can use to join with each other if we want a table where we have all the movies as well as the film categories. We're going to learn about 2 things right now. We're going to learn about how inner join works, and we're going to learn about how aliases work in your SQL queries. So let's go ahead and get to that. So in order to understand how joins work, we need to first create some tables that go against the data that we have currently in all those tables and insert some new ones so that we can join them together. So the first table we're going to create is going to be the actors table. So this is going to have an actor ID and the actor name. I'm going to have all the actors from every single film that we have currently. And then we're also going to create the film actors table, and this will make sense in a second. So this one is going to have the film ID and actor ID as well as a primary key. And now into the actors table are going to go every single name of each actor that are associated with the specific films. So let me go ahead and insert those. And now we also have the film actors, which are going to include their IDs as well as the film IDs. So now you can see that we have 2 separate tables that we just created. If I do select all from the actors table, we can see that we have actor ID as well as the actor name all in this table. And then if we say select all from film underscore actors table, you can see that we have a film ID and an actor ID. So this goes with multiple different tables that we have relationships with. And now we can focus on how to join all this data together and make sense of inner join and left join. Okay, so like I said, we're going to focus on the inner join, and we're also going to add some aliases. And what those are going to look like, let me copy and paste this in here so we can go over what this looks like. First, we have our select statement. And now we're gonna go into what we're selecting. So we have f.filmID, and this will make sense in a second. We have f.title, we have a.actor name. So we're selecting the film ID, we're selecting the title name, as well as the actor name. That's what the results are going to look like. Now, we're gonna select from the films table, and after the films table is a space and an F. So the alias that we want to give our films table is F. So now that anytime we wanna access the films table, all we have to do is type F. as we can see here. After we select the films table and add the alias, we're gonna do and add our inner join statement. This is where we're going to add different tables and join them together. So after you say inner join, we're gonna take on the film actors table and we're gonna give it an alias of FA. So short for film actors. And we're gonna join these two tables on, which is why we have on. So we're gonna select the films table and then the film ID from the films table. If it equals the same film ID from the film actors table, that's where we're gonna join those rows and columns on. We're gonna add another inner join. We can string on as many joins as we want. So in this case, we're gonna do 2 because we're bringing on the actors table. So we're gonna join the actors table and we're gonna give it an alias of A on the fact that any actor IDs from the film actors table is also equals to the actor IDs from the actors table. And lastly, we see order by. That's a statement we haven't gone over yet, but we're gonna order them by the film IDs from the film table. So we're gonna order them by those film IDs, but we're gonna go from the film table. So I know that's a lot to take in, but let's go over it one more time. The final table that we are going to see, we're gonna have 3 different columns. We're gonna see the film ID from the films table. We're gonna see the title from the films table, and then the actor name from the actors table. And now the reason we're not seeing the film actors table in the select column is because 1, we're using the film actors table as a bridge to connect the actor names to their correct films. That's what we did here on this join. Is we took our film actors, and if we look up at the film actors table, we can see that we only have a film ID and an actor ID. Each of them are just numbers, but they correspond to an actor as well as a movie. So we took the data that we have from the film actors table and we joined it on top of the film table. Now, if there was a film ID that matches any of the movies inside of the inside of the films table, then we're gonna match those together, take that data and use it for the results section here. Now that bridge allows us to say, okay, well now we want to join the actors table on top of the film actors table now. Now we can associate actors with the correct movies now that we have the film IDs and the actors that go with them. So we're taking on the actors table in the form of, or in the alias of A on top of film actors. And now if we have any actor IDs that match the film IDs in the film ID, or in the film actors table, we're gonna take that data and then use that here. And then we'll obviously, again, order them by the film ID in the films table. A lot to take in again, but if I hit enter, we're gonna see that we have a very nice formatted table here. Like I said, we're ordering by the f.filmid, which we use up here as well. So everything is ordered chronologically, or in numerical order, 1, 2, 3, 4. And then that film ID will match Inception. And then Leonardo DiCaprio, checks out, was in Inception. Tim Robbins was in Shawshank Redemption. Marlon Brando was in Godfather. So you can see on and on that this does make sense. And now if we were to go and do select all from the films table, we can see that Inception had a film ID of 1. So that checks out right there. And then if we go to select all from the actors table, we can see that Leonardo DiCaprio had an actor ID of 1. So all of that data that we just took in, actor ID of 1 and film ID of 1, matches exactly what it was between all the 3 different tables that we had a relationship with, all to give us one very nice table that we can now use for any form of data analysis or any sort of computation that any of your teams need. And that's really a awesome way to join multiple different tables. This was an example of inner join. Left joins do something similar, but there is a catch between the two that make them unique, as I mentioned before. So let's take a look at what left joins look like. So in order for joins to make sense, we need to add another entry into the films table. So let's go ahead and do that. I have here a single entry that I will copy and paste right now. So I am simply going back into the films table and entering the Mystical Adventures movie. So let me go ahead and hit enter. And then if we do select all from films, we can see that the Mystical Adventures is now added at the very bottom. So now we have 21. So now let me copy the left join query that we want to do here. And now it's going to look very similar to the inner join, where we're taking the film ID from the films table, the title from the films table, and the actor name from the actors table. Again, we're adding the aliases here with the letter F for the films table. We're left joining the film actors table again, using that as the bridge. It's essentially going to be the same query, but if we were to hit enter on this right now, you can see that we still do have the table filled out properly and formatted properly, but we have mystical adventures, but with no actor. So the thing with left joins is even if there is a null value or it's missing a value, the result table will still show even if there isn't an exact match. Now, if we were to go back up to the query where we do the inner join, after we've now added the new movie, we can see that it doesn't show up. So inner join, if there is a null value and the condition isn't fully met, we will not see that in the result table. So for the result table, you see that we only have 20 entries as opposed to the left join where we have the 21, but we just have a missing actor. So to now show that this is actually true, we're going to insert a new actor as well as the new actor IDs to populate the movie. So the movie we added was a fictional movie. So let's go ahead and add the actor's name. So we're going to add Jane Doe and John Smith. And we're also going to add the film actors as well. So 21 and 22. So if we were to run our left join command again, we're going to see that Mystical Adventures actually does populate now. But we're going to see that the Mystical Adventures actually does populate now with the actor name. So this kind of just proves that no matter what, left joins will always show the result table even if the conditions aren't met and there is a null value. There's two more commands we're going to go over. The first one is going to be union, and the second one is going to be union all. These do get a little mixed up with the inner join and left join since they kind of function the same way in terms of how they work, but they are completely different, and let's go over what makes them unique here. So the next two commands are going to be union and union all. These are going to be the last commands that we go over. So we actually use the union operator to string together two select statements. But with the union statement, it actually removes any duplicate rows with the same values. But with union all, you're going to get duplicate rows in the result set table. So it kind of functions the same way as inner join and left join in terms of their differences, but the queries are going to be very different. So let's go ahead and take a look at what that looks like. All right, so back in the terminal, we're going to copy this union command and we're going to go over every single line. So with this command, we're going to select title as name from film. So we're going to use the name alias. We never use the as operator. It is completely optional when giving aliases to use as, so you can omit this when doing it, but it makes it a little bit more clear if we say select title as name. So instead of the column being named title, where it's going to be called name when we get the result table from the films table. And then we're going to add the union operator here and then string on another select statement. So we're going to select the actor name as name from the actors table, and we're going to order them by name. So if I hit enter here, you're going to see that doesn't really make too much sense, but we can see how it works kind of. We have one column since we named them both name down here, and we're putting down this is an actor, this is an actor, this is the name of the movie. So we put together a bunch of names and we order them alphabetically by name. Now, if we were to do that again, but instead we were to change the actor name to actor and hit enter, and it would be the same thing for union all, except remember there are going to be duplicate rows or duplicate values within here. So if we were to scroll down, you can see that we get Tom Hanks twice, whereas in the table above, we only got Tom Hanks once. So again, this is a prime example of union and union all. So we're putting together all the data that we're grabbing using two select statements into one result table. Another cool little thing you can do in SQL that's actually going to be very useful later down the line, especially as a data engineer, is going to be something called subqueries. We've seen them a little bit here by using the parentheses, but let me go ahead and show you what one looks like and then we'll go over it. So let me copy and paste it over. So as you can see here, we have first a select statement where we're selecting the title. Now inside of that, we have a comma, and then inside a set of parentheses, we're using another select statement, but we're selecting the actor name, and again, using aliases and a join. So from actors, alias of A, we're joining the film actors again, using it as a bridge. And then the final result from this select statement is going to be the actor name. And then we're pulling this from films using the alias F. So this is just a string select statement, but a subquery. So before this finishes, we're going to run and find the title from the films table. But then we're also going to look here. SQL will go ahead and execute this query and then add it into the results table. So right now what this is doing is it's retrieving the film's title along with the name of one of its actors. So if we go ahead and enter, you can see that it's kind of the same thing what we did earlier in the course, where we joined two different tables, but we used a subquery instead. Subqueries can be used in multiple different ways. We saw this being used in the select clause here, but we can actually use this also with the in operator. So if we wanted to retrieve films that have either, let's say Leonardo DiCaprio or Tom Hanks, this is what the query would actually look like. So let me go ahead and show you. So we're selecting the title from the films table, where the film ID in, and then this is where our subquery would start. This is where we're going to say, hey, we're looking for any films and we want the name of them if the condition is met here, where the actor's name is either Leonardo DiCaprio or Tom Hanks. So we're looking for both of these movies. So we're going to say, obviously, go into the film actors table and do another join here. So we're adding that condition by joining in other tables, and that's where subquery can really become useful here. So if I enter, you're going to see that we're only going to get the titles back, and Inception, Forrest Gump, and Toy Story are going to be the three movies that contain Leonardo DiCaprio or Tom Hanks. And obviously most of us have seen that, so that checks out. But that is a quick little intro and awesome little thing we can do in SQL subqueries. All right, so now that we've gone through SQL, we can finally get into building our first data pipeline. This is going to evolve as the course progresses, but we're going to start off by building this data pipelines from scratch using a Python script and moving data that way. We're also going to be using Docker to host both of our source and destination databases using Postgres. So you'll get to see how this all coincides and works together with Docker. One thing to note before we keep moving on is there is a repo for this whole project. You can see it here with a README on how to get started and how everything works. If you go up here to the branches, you can see the evolution of this project. So first, we're going to be starting with just the main ELT script, and then we're going to be adding on a cron job to show orchestration. From there, we're going to be adding dbt to the mix, which we'll get into later, and then also Airflow, and then eventually Airbyte. So there's going to be this progression of the course to show kind of how a main ELT script that's created manually would look. And then as we add in more open source tooling, you'll kind of see the power of how everything works together and why, we are using these open source tools in the first place. So just for your reference, make sure to look in the description and you can find this link here to my GitHub repo with everything you need to see just in case you get stuck on something. But for the rest of this project, I'm going to be creating a new directory, but it will directly reference this project. So just keep an eye on this when you're working through it. All right, so I have my terminal open. So let's go ahead and create our first directory here. I'm going to say make dir, and then for here, I'm going to say ELT, and then we're going to cd into ELT. And then from there, we're going to say touch ELT underscore script dot py. Let's also create a Docker file. So I'm going to use Docker Compose in this. So I'm going to say Docker compose.yaml, and let's go ahead and open that up. Okay, so now you can see we have two files that we just created. We have the ELT script, and then we also have the Docker Compose file, all empty. But we're going to fill this out now. The first thing we're going to do is actually fill out this Docker Compose file in order to have the two databases that we need, one being our source, where our data is coming from, and the destination where we want to send data to. So that way we can use the ELT script to move data between those two. Now we're going to use Postgres for this example because we can use it as an open source database. And so let's go ahead and fill this out. So the first thing we need is going to be the version, and version 3 is going to be what I'm going to be using for the Docker Compose file. Now we list our services. So in here, this is where we name our first service. And in this case, I'm going to name it source Postgres. So that's going to be our first service. Now remember, with YAML files, it is very crucial for you to have proper spacing within the file itself. If not, the YAML file is not going to read properly, and it'll actually error out if you don't follow the correct tabbing and indentation. So keep that in mind. So the first thing we're going to do is list the image. And for the image here, I'm just going to say we want to pull from Docker Hub the Postgres image and the latest version of it. So that way we're always up to date. The ports. So this is going to be very important for us in terms of accessing the actual service itself. So with the source and the destination databases, we need to expose the ports so that we can actually access them on the local host. And so for this, I'm going to say we're going to open this up on 5433, and by default we need to do 5432, I believe. So let's go ahead and do that. Now for the networks, we're going to create a network for all of our containers. So you can look at all these services as a single container. In each single container contains an image that the runtime is going to use. And so we actually need to create a network for all of these different containers to talk to. Now I'm going to name it ELT_network, and we will see that at the end of this file, we're going to have well, I can actually just do this right now. So we're going to have a networks section, and in there we'll list the ELT_network. We also have to specify this is going to be a bridge driver. You don't have to worry about what that means, but just know that within the network, all of the containers are going to recognize that this is the network we want it to talk. Remember, that is outside of the services tab. This is going to be its own section here with its own properties. So make sure that you're doing that there. Now, within the source Postgres service, we're going to do some environment variables here that are going to be very important. For the first one, we're going to do the Postgres_database. So this is going to be the name of our database. And for the name, we're going to say source_db. Keep it very simple. The next one we're going to do is going to be the user. So Postgres_user. And this one, let me actually, it should be this way. Not an equal sign. It should be a colon. My bad. This is going to be user Postgres as default. And then obviously the next one is going to be password. This you can change to however you want it to be. I'm going to say secret for this one. And now for the volumes, this is going to make way more sense. And I should actually create this, this folder now, but we're going to create an ELT folder. We're actually going to drag this ELT script into that folder just so we can have some separation between everything. The Docker Compose file will remain in the root. But for the next one, we're going to say volumes. And if we remember what we were talking about in the Docker section, the volumes is how we're able to persist data. So each container can create a volume, and then whatever we're doing inside of that Docker container will contain the data that we're utilizing within that volume. So that data will always persist as long as we do not delete it from within Docker. What I'm going to do here is I'm going to specify the path of, so source, this will make a lot more sense in a second. So source entity init. So we're actually going to have some data that we're going to initialize this Postgres database with, and the init.sql folder or file, sorry, that we're going to create inside of the source DB init folder is what we're going to utilize. And so after we've done that, we're going to map this. So if you see the colon after this directory, we're actually mapping this to the directory within the Docker container. So you could see this as, this is our local directory, and we're going to map this over into the Docker directory. And where this is going to go into the Docker entry point init db.d/init.sql. Okay, so this should be exactly what it looks like for you. And this is going to be the same. It pretty much looks identical. So we're actually going to do this, and I'm going to do shift option down to duplicate this. We're going to add a space here. So this is going to be our very first service here, which is going to be the source database. And now what we want to create here is going to be the destination database. And we're going to change the port here to 5434. We're going to keep this on the network, on the ELT network. Now this also needs to change. So this is going to be destination_db. We'll keep user and password the same. And we actually don't want any volume section here. Why? Because we don't want to save the data every single time. For testing purposes, I want to make sure that the ELT script runs every single time successfully. And so if the data persists, I can't confirm or deny that the ELT script is actually working, so that every single time we kill this Docker container, I want the data to vanish. So that's what we're doing here. For the next service, and the last one we're going to do for this section, is going to be the ELT script. Now, why do we need to create one here? Well, we need to create one in order for Docker to see that we're actually utilizing a script here to send data from the source and destination databases. So we actually have to use Docker for this and use it for the runtime to actually run the script itself instead of us having to manually do it. So what we're going to do here is utilize the manual Docker files at the same time of using Docker Compose. There's different reasons for doing this. I think it's just easier to run certain commands utilizing it this way, and we'll actually see what this is doing. So it's going to look a little different. So we're going to say build. Under the build property, we're going to add some context, and the context is essentially what file we're building off of. And so we're going to say lt_script inside of the root folder. So it's going to be here, and it's going to be root in reference to where the Docker file is. And we're just going to say Docker file, but I'm going to capitalize the D here, because that's what I'm going to do when we create it. Now the command we're going to run, I think that's changed it. The command we're going to run, we're going to put this in curly brackets. We're going to say Python, since this is a Python file, and then elt_script.py. Same thing with the networks. So we're going to say networks and then elt_network there. Now, this is going to be one thing that we learn in Docker. So the depends on property here is that this container depends on other containers. And so if it has any dependencies, this container won't initialize until the other containers it depends on are finished building. And so if I say this depends on both the source as well as the destination services, this script will not run until these two are finished initializing, in which it does take time, which would make sense, right? Because we need to initialize the destination database. Because there is no way for us to move data if there is no data in here yet, and this isn't even ready, we don't want the script to run, or else we're going to run into a lot of errors here. So this is exactly why I wanted to use a Docker container for the ELT script, so that way we can control the way that it functions. So now that we have this going on, we're going to create a new file here. We're going to say Docker file, just like we said. And now within the Docker file, this is where we're going to specify a couple things. So obviously the structure is going to look a little different here, but from is going to be the actual image we want to use. So we're going to say 3.8-slim is going to be the first one that we're going to use here. Now, what we want to do is we want to install Postgres with some command line tools. So we're going to say run and apt-get, since it's running off of Linux, apt-get update and apt-get install y Postgres Hual. So that's going to install the Postgres client there. We're also going to copy. So we're going to copy the contents of the actual ELT script so that the Docker container has access to it. And so we're going to say elt_script.py this. So make sure you have that period at the end. And then the command we're going to run is, again, Python elt_script.py. So that is going to be the structure here. Now, the next thing we're going to do is actually create our source destination and initialize it with some data. So let's go ahead and do that. So if you go over to the repo of the custom ELT project, you're going to see this folder called source_db_init. Now, what this is primarily holding is a SQL file that contains all fake data. So we're going to create a couple tables and then insert values into them. So that's exactly what we're going to go do. So let me go back and switch. I'm going to create a new folder and we're going to name it source_db_init, as we just saw. Inside of there, I'm going to do init.sql. And if you remember, it's exactly what we did here. So we're pointing that exact file over into this directory of the container so that we have access to it. We're creating a mapping of this over into the Docker container, so that way we can actually run the commands to initialize the source database from there. Now, inside of this, what we're going to do is just go in here and copy, and believe I can just copy everything here and paste it. So that's exactly what you're going to do. Just make sure you have access to this. Copy everything that you see inside the folder so we can save some time. I'm going to create a couple tables and insert some fake data for us. Like I mentioned, we're going to save that. And now we can actually go about running this and creating everything. So the way to do that is going to be inside of our ELT script. So let's fill out ELT script now. All right, so we are in our ELT script here, and there's a couple things that we're going to import. So we're going to import the sub process first. So this is how we're allowing to control inputs and outputs and things like that. We're also going to import time. This is going to make sense a little bit later. But the first thing we want to do is obviously double check. And I know that the Docker Compose file checks to make sure that the ELT script will not run unless the source and the destination database are working. But we can also run a fallback just in case. So we're going to create this function here called wait_for_Postgres. And some of the variables we need are going to be the host. We're going to need the max_retries. The default value here is going to be 5. Delay in seconds, we're going to leave at 5. So after that, what goes inside this function, we're going to say retries is 0. While retries is less than max retries, we are going to say try results equals subprocess.run. And then in here, we're going to say pg underscore is ready. This say -h, going to post here, check equals true. Now this is all going to be correlated to Postgres directly. Capture underscore output true, and then the text is true. A couple checks here, right? I think I forgot something here. Move this over, and then we're also going to put an if condition here, if accepting connections. So obviously we're pinging the actual database itself to make sure that it's ready to go. Or if it is accepting connections, we're going to say print successfully connected to Postgres, and then we're also going to return true here, and the accept subprocess dot called process error as e. We're going to say print and f error connecting to Postgres colon here. We're going to use that f here, or sorry, e for the error. Oh, this needs to be inside. Retries. If it errors, we're going to add 1 to the retry plus equals 1. Also going to add another print statement here. And we're going to say f retrying in play seconds. Attempt retries. This is all just for logging here, and then max retries. So here, see where there's an issue here. Outside of the print, we're going to say time.sleep delay seconds, and then outside of the accept print max retries reached exiting in case all else fails, and then we're going to return false. Okay, cool. So that is going to be our check function here. So I know that was a lot, but retries. Spelled that wrong both times. All good. Okay, that should fix it. Cool. Now we don't have any weird squigglies. Now we're going to get into actually building out the initialization of the source database and then moving on to the destination. Well, we can also add this. So we're going to say if not wait underscore or underscore Postgres host equals source underscore Postgres. Then we're going to say exits with the error with code 1 print starting ELT script. Well, now we can actually do this. So we're going to say source underscore config. Open this object here. And so the first thing we need to specify is going to be the DB name. And we're going to be using dump files here. If you're familiar with Postgres, we can use dump files to initialize the actual database, but also use those and dump files into the destination. So that's exactly how we're going to be using this batch script here for our ELT. And so we're going to say source underscore DB is going to be the name of our DB name. It's actually not a sign. It's going to be that. And then let me add our comma here. Same thing here. So we're going to say user is going to be what we specified. So these are all information that we had in the Docker compose file. This is going to be the password. And then the password was secret. Now for this next one, we're going to say host. Now the host should be the name of the service that we put inside of the Docker compose file. So we're going to say source underscore Postgres. That is going to be the source config. Now we're going to do the exact same thing for the destination underscore config. DB name is destination underscore DB. Username is, if I can type properly, Postgres. Password is going to be secret as well. And then the host is going to be destination underscore DB. This destination. Yep, no typos there. Perfect. Now we need to create the dump command for initializing the source data. So underneath here, we're going to say dump underscore command. We're going to say pg underscore dump, which is the command here that we're going to use. The h flag -h will use the source underscore config, and we're going to point to the host since that's our host. Let me make sure that this has a comma for the user. So we're going to say -u, we're going to say source config, and we're going to point it to user. So you can see kind of what we're mapping each individual flag. So the host, user, password, all that stuff too. So we're going to also do -d for the database name, and we're going to point it to source underscore config b name. -f is going to be the file that we're going to use. And where we're pointing that is going to be data underscore dump. It needs to be single quotes, data underscore dump dot c. If we add this flag -w, it will not prompt us for the password, which we don't have to do every single time, which is nice. So the other thing too is we're going to set the environment variable to avoid the password dump. So we're going to say subprocess underscore env equals dict pg password equals source underscore config password. So now we've created a password or PG password environment variable that will not ask us for the password every single time. Now we're going to execute this dump command. So we're going to say subprocess.run dump command, which is the one we just created. Point it to the environment variable that we just created. So subprocess underscore env, and then check equals true. So that's going to dump everything into the source database. Now we actually need to get everything from the source database over to the destination. So we're going to create a load underscore command. And it's going to look pretty much identical to this. So what I'm going to do is copy and paste everything here, but we're going to make some slight modifications. So instead of pg dump, we're going to say psql. So we're actually going to get into the SQL command line tool. We're going to point it to the host, but instead of source, it needs to be destination. The user is also the same. So we need to point it to the destination. Database name is going to be the same. Now we need to, or well, we don't need this since we're not pointing it to a file. Well, we do. What we're actually going to do is concatenate this. So we're going to put two commands here. We're going to do -a, f. We're going to delete the w. And then we're still pointing it to the data.dump.sql file. Now we're going to do the same environment variable with subprocess underscore env equals, we're actually copy and paste this over again, because I mean it's literally the exact same thing, except we're going to be using the destination here, destination config. Now we need to execute the load command. So what we're going to do is we're going to say subprocess.run load command. env is going to equal subprocess underscore env, and then we're going to do the check equals true again, and we're going to print, just for our own purposes, ending ELT script. Cool. So now this is going to be our full-on ELT script. Now, how do we run this? Well, what we're going to do is use Docker to completely run everything here. So let's go ahead and take a look at what that looks like. Because we've made everything and hooked everything up with Docker Compose, it's going to be as simple as this. All we have to do inside of our terminal, obviously make sure that we're in the directory that we created. I'm going to run Docker Compose up. I forgot to do this, so I forgot to change the host to Postgres here. Let me make sure that's that. Okay, so I had a slight error, but all we have to do is we're going to do Docker Compose up. What? Don't say Docker Compose.yaml services.source. Oh, does it not need this? I might have screwed up here again, which is fine. We all make mistakes. So it doesn't actually need this section here. Let's see if that will fix it. We're going to leave this in here. All right, we're running into a couple things here. So /ELT underscore script. So let's just debug this live, because why not? /ELT scripts. So this should just be ELT, I'm pretty sure. There you go. Okay, so just a couple errors here, but hey, nothing that's going to shake us up. But so now that we run Docker Compose up, we're actually going to go through and build out the images. So we're pulling down from the Docker Compose, or from Docker Hub, to build out these images. So now what we can see is we might be running into something here, but as you can see in the logs, and let me pull this over so you can actually see it. So through the logs, what we've done is we've initialized the destination database and the source database, which is good. And then we've also created the database. We've inserted a couple tables and then the values for them, but it looks like we ran into an issue with the ELT scripts. Starting ELT script, so it looks like that was good. Trace back on line 54. Okay, so let's look at our PG script. So you can kind of see like all the little nuances here with creating a batch script. And like this is on purpose. I wanted to make sure that we ran into some issues here. I mean, obviously I would like to not run into issues, but comes with coding, comes with building out these things manually. And we'll see that it gets a little bit easier to deal with later down the line. So on line 54 is when it said that we had a bug here. So subprocess.run dump command. I think this should be a -u or a capital U here. Go ahead and try this one more time. So what we're going to do is Docker Compose down. Type. Oh my God. Okay, so the source is ready to connect. Still running into an issue here on the subprocess. Still on line 54. So we've started the ELT script, return non-zero exit status. Let's try without the check here. So that's not it. DB name, source underscore DB, Postgres. You got secret source, Postgres, destination or Postgres. Okay, so I've deleted the image on Docker. Let's try running this one more time. Let's build the image again and see if it fixes it. Error. Oh, I see the issue. Okay, so I screwed that up. I think that should be good now. So let's Docker compose down. Again, Docker compose up. Just a casual typo error here. I believe it's still not going to work here because I think it's still read the old one. So what I'm going to do is kill this, Docker compose up, or sorry, Docker compose down. Get rid of these. Now let's go into Docker and you can see kind of like what the troubleshooting. So we built this image and I don't think it's changed it. So I'm going to delete that. We're going to go back into the terminal here, say Docker compose up. So we're going to rebuild the image and it should. There we go. Okay. So now you can see after some troubleshooting and then some small typos here and there, we have successfully gotten our logs back. And then at the end, we had our ending ELT script. So the way to check our work now is if we open a new terminal, let me make this a little bit bigger. Let's go back into our other directory. So cd ELT. I'm going to say docker exec, and this is from what we learned in the other tutorial on Docker. So docker exec, and we're going to use the interactive flag here. We're going to grab the name of our ELT underscore script one. So I believe the full name of it should be this. So we're going to grab, I'm sorry, we're not grabbing this. We want to grab the destination name. So we're going to grab ELT underscore Postgres one. So that's going to be the name. Then we're going to say psql. We want to run the command line, the Postgres command line, -u with the user Postgres. Now, if I hit enter, we're going to be in here. The one thing we do need to do is we're going to say /c for connect to the destination underscore DB. So now we can see that we are in the destination database. Now, if I do slash, this is backslash, by the way, or forward slash, I think, is /DT. You can see that all of the tables are now inside of the destination database. Now, if I do select all from actors, I need to add the semicolon. You can see that all the data that we inserted into the source database is now into the destination database. This is now fully working. It is not automated at all, but you can see that our batch script is now successfully working just by simply taking the dump commands that are built into Postgres and then moving those in to the destination database. Now, this is Postgres to Postgres, so this is very, very simple. But you can see that even this is a very basic script, but there's a lot of moving parts when it comes to building out a script manually. And so when things change, or if you're trying to connect Postgres over into, let's say, another database type where you potentially have to match schema and things like that, in this case, we didn't have to worry about that because the same database, same protocol and everything. But if we're working with something else, it can get very, very tricky. So that's why we're going to be implementing a lot more open source tooling. But for this next part, we're actually going to add a cron job to this to automate the script a little bit, because as of right now, we are simply just manually triggering this. So if we needed to do this every day, every 3 days, we could actually add that in here. So let's go ahead and do that now. Okay, so actually I lied. The next evolution is not going to be the cron job next. It's actually going to be DBT. DBT is going to be an open source tool that we can utilize here in order to write custom transformations or custom models on top of the data that we've just sent into the destination database. So you can take, for example, that we had a use case where this destination database is primarily going to be used by data analysts or some sort of data scientists, and they need their data formatted or structured in a certain way where we're combining certain tables together. They can't write SQL or something like that, and they actually just need it a certain way or something along those lines. We can use DBT to have those custom models so that by the time the data is inside the destination, we can run DBT on top of that data and then write custom models here, creating custom tables and things like that. And it allows us to have certain capabilities. It also allows us to even write Python to run SQL scripts and things like that. So let's go ahead and see what that looks like and implement it now. There are a couple prerequisites you need in order to run DBT successfully on your machine or even using Docker. So let's go ahead and take a look at what that looks like and actually get it installed. All right, so I'm here on the DBT docs, which we will also list down in the description just so you can get to it pretty easily. Now, there is some things you need to do do locally. Not everything you can do here through Docker. So the first thing you need to do is, obviously I'm on a Mac, so most of the instructions here are going to be for Mac, but you do need to have this installed locally. And the way to do that is if you probably have pip, if you have Python installed. And so you're going to follow all these instructions. I think you could pretty much skip these ones right here. You're gonna want to follow this one for sure. I think actually you could probably skip that one too. The main one here is installing the actual adapter. You're not just installing the adapter, but you're also installing DBT core, which is the open source version of DBT. Now I've already done this, but if you run dbt install dbt-postgres, we're installing the adapter of Postgres that utilizes DBT as well as DBT core. You're gonna go ahead and run that locally. I've already done that. As you could see here, so if I say dbt version, you can see that it's going to list pretty much. I have 1.62 installed. I'm not going to update for the sake of this tutorial, but there's 1.66 and I have the Postgres version installed as well. So make sure you go through this installation really quickly, and that way we can actually go through and create our models. So make sure you do that. That is just the only prerequisite for this section. Okay, so now that we have DBT installed, let me go ahead and show you how we can initialize a project here. So it's as simple as dbt init. So we're gonna run dbt init inside of the root directory, excuse me. Now it's gonna ask us for the name of our project. We're gonna say custom underscore Postgres. So it's going to say custom underscore Postgres, and you can see it's creating these folders here for us. Now we have the database we would like to use. It's asking us right here for Postgres, and obviously it's the only adapter that we installed. So we're going to hit number 1, and therefore it's created two folders actually. If we take a look on the left-hand side, it's created logs for us. So we now have logs for anything regarding DBT, as well as our project for DBT. So it has a couple folders here: analysis, macros, models, seeds, snapshots, and tests. Primarily what we're going to be focusing on is the models and macros for now. And then the rest of it is kind of like, you can learn as you go. But for the sake of this tutorial, we're going to be focusing on these folders here. So there are other couple things that we need to do in order to set up the project itself before we actually write our models. So one thing we actually have to do is going to be this. So I've just copy and pasted this one command, but you're going to do nano, and inside of the complete root of your local machine, when you install DBT using pip, it actually creates this .dbt directory, and inside that folder is a profiles.yaml file. So what we're going to do is go in there, and you can see that I've already set this up, but inside of the dev profile, it does say Postgres underscore transformations. I'm going to go ahead and change this because this is now different. So what I've done now is I'm going to change the name of this because it's no longer Postgres transformations. That's what I normally did. This is going to be custom underscore Postgres. You can see it's done that down here. It is actually done that down here. Actually, you know what? I'm probably just going to do that instead. I'm going to Postgres. So now that we're inside of this folder, you can see that I've already done this prior. But if we were to go down here into the custom Postgres profile, which is created for me because of this new project, we can see here there's two different outputs. There's prod and dev. We're going to be primarily focusing on dev, and we do need to fill out the actual information here. So inside of host, I'm actually going to do host.docker.internal, which is needed in order for DBT to actually recognize the Docker containers that we are trying to access here, which is going to be our destination database. So make sure that this says host.docker.internal, and it'll read the actual network or IP address of your Docker container for the destination database. For the port here, this is going to be 5434, I'm pretty sure, for the destination. For the user, we're going to change this over to Postgres. For the password, we're going to change this over to secret. DB name will be destination underscore DB. And then I forget what I actually put for the schema here. Schema should be public. And then I forgot to fill out the threads here. So let's change this to 1. All right. So, and the target here is going to be dev. So obviously make sure that says it. By default, it should just target the dev profile. But now that we have our information filled out here, it should have the correct information to connect to our destination database. I believe if I do write out, maybe not write out, but if we say X, save modified, we're going to hit yes, tab to complete, and hit enter. Okay. So this should have saved it. Now, the other thing to do here is inside of the dbt_project.yaml file, the one thing to note is that obviously the profile we just wrote is the custom_Postgres. You don't have to change anything here except for this bottom section. Inside of the bottom section is going to be how we're forming our models. Now, inside of the models folder, you can see that there's an example folder and then a couple of models here. What we're actually going to do is we're going to change this. There's a couple options inside the materials section, but because we're using Postgres tables, we actually want to change this to table. If you keep it as view, we're actually not going to see any of the tables that we created come through or anything like that, or dbt is not going to be able to recognize it. So we have to change it to a table. Now that we've done that, we can actually go in and write our models. So let's go ahead and do that. All right, so we are inside of the models folder here, and inside of this example folder are some custom examples that they have created for us. We don't really need to see this because we're going to be writing our own. So I'm actually going to go ahead and delete both of these. We're going to keep the schema.yaml for now. Well, we're going to reference that later, but let's create our models here. So you can think of models as just SQL files. We're just querying the data, but we're morphing the data around to the needs that we need. So we just do it once here, and then once the destination database has its data, everything that we've queried here, all the modifications and the new tables that we've created will end up inside of the destination database. And you'll see what I mean by all that once we have it all hooked up. The first thing we need to do is actually source the data itself, because it can't just simply reference tables inside of a destination database without having the actual reference itself. So what we're going to do is we're going to create our first one. So we're going to say film_actors, which is a table that we're actually writing over into the destination database. And this is simply just creating a reference for us to create the custom models. So this isn't necessarily a custom model here. So we're going to write some SQL here, select all from, and then we're going to do double curly brackets here. And inside of that, we're going to say the source of our data is going to come from destination_database. And the name it for this that we're going to reference it from is going to be film_actors. We're going to need to wrap both of these in single quotes. Very cool. Now, what we've done is we've sourced the destination database and we've taken the film actors table. And now we have a film actors reference. Let me go ahead and copy and paste this. We're going to do that again for the actors table. So actors.sql. We're going to paste this in here and we're simply going to change this over to actors. And we're going to do the same for films.sql. So we have our references. Now we can actually create our custom models. But again, before we do that, we have to have some prerequisite work. So for the schemas, these are our custom models here, our dbt models. And we do have to specify what the schema of these are going to be so that if we do need to test anything, which you should be testing, you can run a model or you can run dbt against all of these SQL files. And if it doesn't match what we've specified inside the schema, we're going to get thrown back errors. So you should definitely always do this. What I'm going to do is I'm going to head over into our file here, and I'm going to look into the models and example folder, and we're going to have a couple things. So schema.yaml is what we want. We see that there's a films table here, and every bit of schema here for that one, the actors, film ratings. I think I need the film ratings one too as a, yeah, that's fine. So what we're going to actually just do here is copy and paste this whole thing. So I implore you to do that too. We're going to paste that in there, and now we have the schema for all the tables that we just added. Now, the other thing too that we need to do is we're going to go ahead and copy over the sources.yaml. So now we're specifying the raw data from the destination database. So I'm going to copy this as well. And you can see film actor and film actors, literally the exact tables that we just copied. So we're going to go in here and create a new file called sources.yaml and paste everything that we just saw. So now we actually have sources that we can point to regarding these files or tables, essentially, that we're querying from. So you can see, if we think about this from the top down, data is theoretically already written inside of the destination database. dbt is going to run after we've moved data over, so the data is already there. And from there, what we're doing is taking in the data, so that way we can modify it and create a custom model with that data. So all we're doing here is referencing data that we already have. Now let's go in and create the custom models to formulate and modify the data we have into a table that we want. Okay, so the first model we're going to create inside of the example folder, I'm going to name film_ratings.sql. So what we're going to be doing is appending the films as well as the actors together to create one table, but it's going to be primarily focused on the film ratings. So let's get to it. All right, so what we're going to do inside of this file is we're actually going to create two different tables and then use a join to create one, if that makes sense. So the first one we're going to call is with films underscore with ratings as, and then this is where we're going to run our SQL to create this table. So we're going to say select film underscore ID title, release underscore date. Make sure you're adding commas, price, rating. These are all from the table that we already have. This is going to be user underscore rating. This is where we add something very specific. So this is going to be a case. So what the case is, kind of like you can think of an if statement per se. So we're going to say when user underscore rating is greater than or equals to, let's say 4.5, then we want the rating to say excellent. We're going to add another one where user rating is going to be greater than or equals to 4.0. So kind of like in the in-between there. And we're going to say that we want the rating to read good. And then the last one we're going to do is going to be user rating is going to be greater than or equals to 3.0. Then we're going to say that this is going to be average. Else, we're going to label it as poor. And we're going to end as rating underscore category. So that ends this case statement here. And this is where the reference comes in. So we're going to say from, and we're going to open the double curly brackets again. And if we say ref parentheses films, we're going to be pulling from this here because we labeled it as films. So now we can actually reference it here within this little query here. One thing I forgot to mention for this specifically is you saw that we say with and as, or with films with ratings. This is actually what's referred to as a CTE or common table expression. So you can see this as a wrapper of this query, kind of like a subquery per se, but it makes it easy to write queries that are maintainable. And they're also scoped just to this CTE. So it will not like go outside of this. So this allows us to write subqueries and then ultimately reference them later inside of this file. So it is actually a really, really nice part of DBT that lets us write CTEs to kind of formulate these custom models. So that's just something I forgot to mention when we were first writing this, but remember this is a CTE or common table expression. All right, so now that we have our first CTE, so let's write the second one. I added a comma after the CTE so that way we can string on another one. This one is going to be films with underscore actors as, and then that's going to open our CTE here. Our second one, so we're going to say select, and we're going to do the alias here, f.film underscore ID, f.title, and then we're going to do a string aggregator or string aggregation with a.actor underscore name. And we're going to append it with a comma there, and we're going to do as actors. So we're aggregating actor names for each film here. And then we're also going to hit the reference. So from double curly brackets, reference films. And then obviously we're going to enable the alias here with F. It auto completes that, but there we go. So then we're also going to left join film underscore actors table. And we're going to give that FA for film actors on f.film underscore ID if it equals the film actors dot film ID. Perfect. We're going to do another left join here, referencing this left join we need this. So let's go ahead and do that. So forgot the curly brackets, or I'm sorry, the parentheses and single quotes there. Let's add the actors for this reference. Obviously this one is going to be A on fa.actor underscore ID if it equals the a.actor underscore ID. And then we're going to group by the f.film underscore ID and the f.title. Okay, so that's going to be the second CTE. So we have two now, technically two queries, films with ratings and the films with actors. So we've taken the film ID and the title and we've joined the two tables that we had here. We had the film actors and the actors table. So these are obviously, we worked with these before, but the film actors and the actors is the bridge to the films table. So now we can actually join them to create one. So now we're going to have the main query here. We're going to select fwf.asterisk here, and we're going to say fwa film with actors dot actors from the films underscore with, now you can see underscore ratings. You can see how we're referencing the actual CTE now. And then we're going to label this as FWF for the alias. Then we're going to say left join films with actors, which we're going to label FWA on FWF dot film underscore ID if it equals the film with actors dot film underscore ID. Now we're creating essentially what could be two tables using the references we've created. And now we're actually joining them together using this custom model. Now, if we were to want to run this, we now need to set up the Docker container for DBT. So let's go ahead and do that and then run this custom model just to see what it would look like. Okay, so we are back inside of our Docker Compose file. Let's go ahead and add the DBT service. So underneath the ELT script, I'm going to say DBT, which is going to be the name of our service. The image I want to use is going to be ghcr.io/dbt labs/dbt Postgres, and then the version is 1.47. This, as of right now, at the time of this recording, is most likely out of date, but it's just what I use, so I'm going to go ahead and run with it. The command I'm going to run here, I'm actually going to run a couple. Now, I'm going to open this square brackets, and the first one I'm going to do is run. So this is technically dbt run. Dbt run is the command you would use in order to run your models on top of the destination. So I'm going to string a couple here. So we're going to say run, and then we're actually going to we're going to point to the profiles directory. So if I do double hyphen profiles hyphen dir, not period, I need a comma. We're going to say that is going to be in the root here. And then if we're going to point to the project directory, then we're going to point to /dbt, which is the name, essentially going to be the name of our project directory here. The one thing I also want to do, well, we can leave this out for now, actually. So after that, we're going to do networks, and this will be alt_network, so we can keep it on the same network here. And now we're going to point some volumes here. So with the volumes, we have the actual project itself. So you notice I said /dbt. So here we're actually going to create another mapping to point to /dbt, because if we remember correctly, on Docker containers, every directory here is pretty much going to be pointing to the directory inside of the actual Docker container and not your local machine. So you have to map the Docker container to look at where the actual project is going to be on your local machine. So we're going to create that mapping. And this is going to be ./custom_Postgres. And then from there, we're going to do the colon to create the mapping to the container path. And then the container path is simply just going to be /dbt, which we've pointed right here. Now we need to create another volume here. Let me add a space here because that requires a space. We're going to point to the dbt profile that we did. So we're going to need the squiggly tilde. We're going to need squiggly /dbt. And we're going to point this over into the root, which is where we've pointed, if I could spell normally. This is where the profiles directory was, which is going to be in /root. So now we're mapping our local dbt folder with the profiles.yaml file to the /root of the Docker container. Hopefully that makes a bunch of sense, because in my mind it kind of does. So we're also going to say depends on the ELT_script. We want dbt only to run, because remember, when this container starts, we're running this command. And if we run dbt run on top of the destination database without it having any data, this will not work, because it has nothing to reference and it has nothing to write data on. So we need this to make sure that it depends on the ELT script, and the ELT script depends on the two databases. So this is working down the line. We've essentially created a work line here. And then for the environments, we need two here. So we need dbt_profile. This one is going to be, it's going to be default. And then we have another one. This one doesn't need a hyphen actually, because we made that mistake last time. And then we need dbt_target. And this one is going to be dev. So this is going to be everything we need for the dbt container. Now, all we need to do, go ahead and clear this. I don't think Docker Compose down. Go and Docker Compose down everything. I think the volumes are still up, but that's totally fine. So now we're going to do Docker Compose up. Did I type that correctly? hcr.io/dbt-lab/dbt-postgres 7. Oh, 1.7. Okay, that's another one, another typo. There we go. So we're going to go ahead and let that run here. So ELT script exited with code 0, so that's a good sign. Now the DBT one should pop up. Invalid, not a project, missing DBT underscore project.yaml file. Okay, so invalid project directory. Project directory here, custom underscore Postgres. Maybe we do not need this. Let's go ahead and clear this. Let's do docker down /b and then, so maybe custom. Oh, I'm dumb. It should have been an underscore. You can see all the typos and everything really does make a difference here. So let's run that again, and that should map to the correct project now, hopefully. There we go. So it's ran successfully, I think. Unable to do partial parsing. Encountered an error sources.yaml, runtime error sources.yaml. List of actors, film actors, raw error while parsing a block mapping Unicode. Okay, so there was an error in our sources file here somewhere. That might have been it. 13 and 14. Film underscore actors. Okay, let's do this one more time. I think my cat may have done something with that. So you can see it's a lot of back and forth here. Script ran successfully. Okay, it's taking a little bit longer, which is totally fine here. Model FIMS which was not found. There's a lot of typos going on. Film ratings. So if we go into film underscore rating, reference films, FIMS. Okay, here's the typo. Let's Docker compose down again. So also, if you're curious, if I'm Docker composing down -v, I'm actually killing the volumes every single time just to make sure that everything is working, even if we're starting straight from the beginning without any data persisting. So that's the only reason why I'm doing that. So now we Docker compose up again. This should work unless I've made even more typos. Okay, so we're doing that again. There we go. Okay, so now you can see that we've successfully run our models. So we've created a couple models here. The first one was the actors. The first one was the film actors. And the third one was the films. So these are all our references. So we've successfully taken that in, but now we've actually done the fourth one, which is the model for the film underscore ratings. So you can see that that's actually worked now. Now, if we were to go docker exec -it, and then I think it was ELT destination underscore Postgres -1. And then we do psql -u Postgres. So then we go here, we do C destination underscore DB. We connect there and then /pt. So now you can see film underscore ratings, which is the new table that we've written in DBT is actually written now. If we select all from film underscore ratings and then with the semicolon, you can see that if I move this over, it's a little big, but you can see that our case has gone in here. It's kind of cut off just because of the way that my terminal looks, but you can see everything is in there. So we have our actors, we have our film ID, we have the release date, the price, but the most important part is the rating that we've created here. So the case statement worked successfully. So anything above a 4.5 was excellent. Anything below that between 4.0 and 4.4 was good, and you had no average one. So you could see that we've actually created this custom model successfully, along with the actor and the actor name. So you had Inception with Leonardo DiCaprio. It just looks a little weird because of the way that if I were to do this here, so let's do the same one. So now you can see it looks a little, well, it still looks a little weird, but anyways, you can see that it works. So that is creating a simple model in DBT. Now let's look at some other advanced options you can do inside of DBT to make your queries a little bit more dynamic is the best way to put it. Okay, so now that we've actually created the models, I told you that we're going to get into some advanced stuff with DBT, and that's why I mentioned the macros folder. So you can think of macros as sort of like a reusable components of DBT, where you may have some sort of queries that you want to reuse and is universal through pretty much all your models. So what if you could just create a macro where you didn't have to rewrite the same thing every single time? Well, you can absolutely do that with macros. Let's take the film underscore ratings file, for example. Let's say we wanted to generate this every single time. Now that's probably not going to happen, but let's say we wanted to do it. And so let's just go ahead and actually take the whole file and cut it. Now inside of the macros folder, what we're going to create is we're going to say film underscore ratings underscore macro dot SQL file. Everything's going to be a SQL file here. Now, what we're going to do is we're going to start the file with curly brackets. Both sides are going to have a parentheses, so double parentheses. And inside that, we're going to say macro generate underscore film underscore ratings. And then we're going to parentheses after. Now, the end of the macro is also going to have curly brackets, is also going to have double parentheses, but inside the parentheses, or I'm sorry, inside of the percent signs, you're going to say end macro in one word. Now, in between that is where your macro is going to go. So I'm going to go ahead and paste what we just took from film ratings into the macro. Now, film underscore ratings has nothing. But if we were to go inside of film ratings now, all we have to say is two curly brackets, and we're going to call the generate film underscore ratings macro. So you can see that this is the model that we're actually writing, and the macros never actually gets written. But if I were to go back into our terminal here, and let's close this, and let's say docker compose down -v. So let's kill the volumes here. We're going to say docker compose up, and it's going to run through everything all over again. So let's go ahead and let that go through really quickly. dbt is going to start running, and then you can see we still have 4 models being written. If we go back now over to the destination database, /c destination underscore db, and then /dt, the film underscore ratings table is still getting written. And if I do select all from film underscore ratings, you can see that we're still writing exactly what we wrote in film underscore ratings, but we've only been using the macro. So you can see that literally anything inside of the macro file in between this section here and here is going to be written exactly as shown. So if I were to say, let's create a macro for this case, which probably is more plausible than anything. So if I wanted to say generate ratings underscore macro .sql, and we wanted to do the same thing where we go, let's just percent sign this generate ratings, and then we're going to end macro, right? And then we paste this inside. All we have to do now is then just say generate ratings, call that, and then we should be able to do the same thing. If we do this, docker compose down, docker compose up, let that run again. Yes, it takes a little bit of time to run it every single time, but this is just what it comes with. It'd be much harder. Is undefined, undefined, generate underscore ratings. It's not generate underscore ratings. It's generate underscore rating. Wondering if you can't call CTEs here. So now you can see kind of how macros could work. Is it allows you to have reusable queries throughout your whole DBT project, essentially, to just plug and play in and not have to rewrite the same thing every single time. So if you have reusable queries that you can use, go ahead and use macros, because it's very, very efficient in terms of not having to, it implores the dry method of software engineering where, don't repeat yourself. You don't have to repeat yourself every single time if you have the same queries over and over and over again. So utilize macros when you can. Now let's move over into Jinjas, which is another feature of DBT. Okay, so this next section that I just mentioned with Jinjas are essentially what allow you to create conditionals or add control structures to your SQL queries. So for example, that we're going to use is, let's say we wanted to select a specific title, but using a Jinja, so we didn't have to actually put it within our actual SQL query. That's what it allows us to do. It could allow you to select, do we want to use the prod target instead of the dev target inside of our DBT project? Then we could do that as well. And we can change the way that queries are done, again, adding a control structure. So let's go ahead and inside of our example folder, we're going to create a file called specific underscore movie.sql. And inside of that is where we're going to start with our Jinja here. So again, starts with a curly bracket and then 2% signs. And inside of that, we're going to say sets. So when you see sets, that is essentially what is starting our control structure here. And we're going to set film underscore title to equal, for this example, we're going to say Dunkirk, because I know that's going to be a movie inside of the demo or the test database here. So Dunkirk is going to be a movie that we're going to look for, right? Now inside of that, we're going to say select. So this is the actual query itself. Select all from, and we're going to reference the films table here, where best practice here, where title equals, and then we can say in the single quotes, film underscore title. So that is obviously the variable that we've set up here, right? That's going to be our Jinja here. We're setting a control structure where we only want to select the title where dynamically the value we've set here is Dunkirk. And obviously this can be anything we want it to be. But so let's go ahead and save that and then run our Docker compose up here and let everything go. When dbt runs, we should have a fifth model that runs, which is going to be our specific movie. And so let's go ahead and let that run here. There's going to be the fifth. It's all passed. Very good. Let's run our destination database and /c into it. So destination _db /dt, and you can see specific movie is now a table inside of this database. And so if I say select all from specific _movie, you can see Dunkirk as well as all of its information, including the film ID, the release date, price, rating, and user rating, is going to be in there because we've used the Jinja in there. Now it allows you to pretty much do anything you want. You know, if we wanted to go into the macro here and create conditionals where we have an excellent condition, a good condition, or an average condition, and we set those to be this number, we can absolutely do that. And it allows us to do that outside of the query. So that way we can know that up here, we can set it to a different movie. You know, if we wanted to do Inception, we're only changing it Inception. Pretty sure that's how you spell it. If it's not, that's going to be very awkward. But so let's do this. Docker compose down V, Docker compose up. Let's run this again. And so when we run this, we should see that the specific movie has then changed over to Inception instead of Dunkirk, therefore showing that the Jinja works, and it allows for a little bit more readability, right? Because you can see that our film title, we've set it to a variable. We're not, you know, manually searching for a movie here. And then we're going to do select all from a specific movie. And now you can see Inception is now there. So again, a very simple example of what a Jinja is and kind of how it works, but go ahead and play with it. I implore you to kind of, you know, integrate Jinjas with macros to really, you know, use the full power of macros and Jinjas together. And I think it could really 10x your SQL queries and your custom models from within dbt and really just excel that process of the whole data engineering / data analytics process altogether. Okay, so as I've mentioned before, we're going to be adding a cron job to this. Not ideal, I guess you could say, in the sense of that, like, it's not necessarily the best implementation, I guess you could say, but there are a lot of other people out there that use cron jobs. I'm going to show you the way you can implement a cron job because, again, you don't want to manually be triggering these data syncs or this pipeline to be running on your own. You kind of want some automation here. So the first thing we're going to do is add the cron job. I'll show you how you can do that in this type of implementation. Obviously, there's different ways to implement it, but this will eventually evolve into us adding a tool called Airflow. Airflow is going to be an orchestration tool that easily allow us to kind of have more control than a cron job over each individual task inside of our project, allow us to schedule it properly. I think the best thing that you can have is more control outside of just scheduling when it runs. And so let me go ahead and show you how the cron job works first, and then we'll move into Airflow and other orchestration tools like that. Okay, so for the cron job, the main file we got to go into is going to be the Docker file. Now, because we're primarily only working on the ELT script and we want to schedule that, this is where we're going to run everything. So just going to be some slight modifications here. So the one thing we're going to do is we're going to add cron to the end of the list of installs that we're going to do. So we're going to run for Postgres client as well as cron. Underneath here, now what we're going to do is we're going to create a new file called start.sh. Now this is going to be a bash script that we run. So this sits in the root directory and we'll modify this later. But above this copy script, or above this copy command that we have, we're going to add another one. And this one's going to be start.sh. And we're going to copy this over to the app directory of Docker. So that Docker now has the start.sh file within its own container here. The working directory is going to be the app. So we're going to say workdir is going to be /app here. In between work directory and command, this is where we're going to add the cron job. Now, for this example, we're going to run the script, let's say every day at 3 a.m. So we're going to do a run command here, and then we're going to echo, and then in quotes, we're going to say 0 space 3 and then 3 asterisks. And I'm sure there's like, you know, sources online that can show you kind of like how to properly write a cron job for a specific time. This is just the one that I have. Now we're going to say python/app/ELT_script.py. And then outside of that, we're going to do the divider here. And then we're going to say cron tab. Now we're going to save this. And then if we go back into start.sh, this is where we're going to write how to actually start the cron daemon. So at the very top, we're going to say cron and that pretty much is what's going to run the cron and have it run in the background. And then python/app/ELT_script.py. What this is going to do is we have the bash script and it's in our working directory. We're going to run this command here when the Docker container starts. And now this bash script is going to run the cron daemon in the background and then run this every single time it's 3 a.m. And so we'll run the bash script at 3 a.m. every single time due to this cron. So again, a very simple implementation of how the cron is supposed to work. Obviously, it's hard to demonstrate this because it's 6:50 p.m. right now. So I can't really just wait here until 3 a.m. But now, at 3 a.m. every single time, this will run. So yeah, that's essentially how this cron job is going to work. Now let's move into how Airflow is going to play in the mix and how we can now orchestrate this using a real open source tool that's out there in the wild. All right, so in this section, we're going to be adding Airflow to our project. And as I mentioned before, Airflow is an orchestration tool, open source, that allows you to essentially have a top-down view of every single task and say, hey, I want my ELT script to run first. And then once this finishes and is successful, and that's exactly what we're going to do here. We're going to orchestrate all of our tools and all of the working pieces that we have right now to make sure that they work sequentially here. And, you know, there's a lot of different use cases with Airflow or other open source tools like Daxter or Prefect, but we're simply going to be using Airflow as our orchestration tool to make sure that our pipeline is working the way we want it to and has some form of automation here. All right, so first thing we're going to do is going to create a new folder here. And we're going to name this Airflow. And inside of Airflow, we're going to have another folder called DAGs. And a DAG is simply a directed acyclic graph, I think is how you pronounce the A part. But so the DAG is what we write in order to orchestrate all of our tasks together and also put in some of our logic for each task. So that's what we're going to be writing here. In DBT, we were writing models, custom models. In Airflow, we write DAGs, or in any orchestration tool, we're going to be writing a DAG. So that is another term for you to put into your brain as knowledge to know as a data engineer. The other thing we're also going to create here is a file, not inside of the DAGs folder. So this is going to go into the root folder of Airflow, but this is going to be airflow.cfg. I think we just need this for Airflow specifically. We don't need to put anything in it, but if you needed to do anything with your configuration of Airflow, this is going to be the file that you're going to put it in. Now that we have this structure put together, let's go ahead and go into our Docker compose file and then add the Airflow service. This is going to be a little extensive because it is a big service. So we're going to take our time with this one and really go through it. All right, so underneath the DBT section, we're going to go here and add a couple spaces because we're actually going to be adding quite a bit of new services here that have to work with Airflow. It would be a lot, but I've narrowed it down to be very minimal here, so we don't have to worry about that too much. So the first thing we're actually going to add is going to be another Postgres service. And why are we adding another Postgres service here? Well, it's because Airflow needs a database to store its metadata and its logs. So this is the database that's going to go into. It's going to be the same look here. We're going to say Postgres and the latest image here, right? Networks, we're going to tie into the ELT_network. And then for the environment, let's do this. So environment, we're going to do Postgres user is going to equal Airflow here. We have Postgres password, which is going to equal also Airflow. And then for the Postgres DB, this is going to be Airflow. So very simple there. Now fix this. Now that's the metadata service, so you can name that whatever you want, but for simplicity's sake, I'm gonna keep it as Postgres. The next thing we need to do is going to be an init Airflow service. Now for the init Airflow service, what this is primarily doing here is initializing the user and the database that we just created all together for Airflow. So we're going to add 2 more services after this, but this is a very important service for us because without this, we're not going to have the admin user and be able to create new connections and things like that. So this is very important here. Now, the image that we're going to add is going to be Apache. So the Apache project, open source project, Airflow, and then latest. This is going to be the same for pretty much every single, I think it's going to be the same for every single one, but I could be wrong. Anyway, so image, this is going to depend on Postgres because we need that database to be initialized essentially before we initialize Airflow, because without it, we're going to have some errors here. Networks, again, we're going to say ELT_network. For the environment, we're going to say, this is going to be a long one. So Airflow __, so 2 underscores, database __ SQL _alchemy _con for connection is going to equal, and this is going to be pointing to our Postgres database here that we just created. So Postgres plus sy copg2 / Airflow for username and password here at Postgres / Airflow. Okay, so that's a long one, but that's going to be the environment there. Now, last one we need is a command. The command, we're going to say less than or greater than sign, and we're going to say bash -c in quotes Airflow db init to initialize the database for Airflow, and string on another one here, push it over here. There's the Airflow users create. So this is where we create the admin account. Username Airflow, password is going to be password. Let's just say first name is going to be John, last name is going to be Doe. We want the role here to be admin, and then the email we need to set, let's just say admin@sample. Cool. All right, so that's a pretty long one there already. Let's go down here into the next service that we need to create. So that's our initialization of Airflow. Now we're gonna get into the actual like UI of Airflow, which is going to be the web server service. Let me add some spacing here. The image, we're actually gonna create a Docker file for this. So we need to do that first. Now in the root of the directory here, we're gonna say Docker file, and then in here, we're gonna say from Apache /Airflow latest. So the same thing that we did with the initialization of Airflow. Now we're gonna say run pip install Apache Airflow providers Docker. Now this is going to come in handy later on, but we do need this in order to run this command here. Airflow has a bunch of different providers for you to access different integrations, Docker being one of them. And there's going to be another couple ones that we're going to use later down the line, but Docker is the one we need. So now that we have this, we're going to go back into our Docker compose file. And then for the build section, we're going to say build context, just add the dot here. The Docker file, we're going to point to Docker file, just capitalize this part. The user here is going to be root, because we want the root here. And then it depends on the Postgres service. So we do not want Airflow to initialize until the metadata store essentially is initialized. Networks, we're going to point over to the ELT network. And this is going to be a special one here. So extra hosts. Extra hosts is going to be an interesting one because we are running everything on Docker. We actually need this for special reasons that'll come up later. But so in double quotes, we're going to say host.docker.internal, and then we're actually going to point that to host gateway. Okay, so that points to inside Docker, the host gateway. So that's going to come in handy later. So now that we have that, we're going to point to some volumes here. Now the volumes are going to be very important. So we have our DAGs that we need to find. So within that, we're going to say ./airflow/DAGs. So now we have our DAGs folder. Now we need to map it. So we're going to map it to the /opt/airflow/DAGs. So now we have the same directory of DAGs inside the opt folder, and then it'll go to Airflow DAGs. So now we have that inside of our Docker container. Next one is going to be the ELT script that we have because we need access to that. So ./ELT is the folder that we have. And then we're going to say, we're going to map that over again to /opt/airflow/ELT. So now we have our own ELT folder with the script and all of its contents, which is just the bash script there. Now we need the transformations because we're also going to be orchestrating not only the script, but we're also going to be orchestrating DBT, and we need access to those files. So we're going to say /custom Postgres. That is going to map over to /opt/PL dbt. So now we have the dbt folder in there. We're going to need the profiles for dbt. So we're going to say tilde /.dbt, and then we're going to point that over to /root/dot. Okay, hopefully this is all making sense here. This one is going to be opening up, essentially giving Airflow access to essentially the Docker network. So this is going to be very important here. So we're going to say /var/run/docker.sock. We're giving access to the socket there, /var, and we're mapping it to /var/run/docker. Okay, cool. Now for the environment variables, and this is going to get really long here. So we're going to get environment variables here. The first one is going to be load_x equals n. These are all just going to be needed for Airflow. Executor equals local, and we're going to say Airflow, and then we're mapping this back to the database here. So __database alchemy con. So I have just copy and paste this over actually. Cool. So I've got that now. One thing Airflow does need is it's going to need a fernet key. _fernet_key. So that's only one underscore there. And then we're gonna say equals. It essentially encrypts the username and password. It's for a security reason. We're just gonna do that because, for the sake of this video. So I've actually, if we go to orchestration Airflow, I have this command, which I will also leave for you in the description, but this is essentially going to generate our fernet key for us. And what we're going to do is copy and paste that command into our terminal, and it should spit out to us a key, which we will then use and paste here. So now that is our fernet key that we're going to just leave in and will be used for encryption's sake, right? And for security. There's that. Now we're gonna need Airflow __ web server __ default user _ username. And that's just going to be Airflow. I'm actually gonna copy this and then just change the last bit here to say, password. And this was going to be password. Cool. Next environment variable here. We're gonna go Airflow _1_www _user _username equals Airflow. Same thing. Copy and paste this password. And then the last thing we need is going to be Airflow _web server __ secret _ key. That's just going to be secret. Cool. All right, last bits here. We're going to say ports. So we need to expose the ports here. This is going to sit on port 8080. So we're going to say 8080 here. So that's how we're going to access the web server, and the command we're going to run this web server. Cool. Now, the one thing that's going to save us some time here is we're going to copy and duplicate the web server portion, because it's going to be the exact same. But now, instead of web server, this is going to be the scheduler. So it literally is going to be the exact same. So I don't think we need to change anything. No. So the scheduler is a needed worker for Airflow. And so we absolutely need both of these. One, the web server to give us a UI to access. And then we're also going to need the scheduler to schedule all of our jobs here. And they're going to point to the same exact thing. Okay, so that is going to be the setup for Airflow. Now let's go into writing our first DAG in order to actually orchestrate all of our tasks here. Okay, so we're gonna go into our DAGs folder here, and we're gonna create a new folder. And in that folder is going to be ELT_dag.py. So we're gonna be writing some Python here. Now, the first things we're going to import are gonna be from datetime, import date time and time delta. So we're going to be using some time values here. The next one is going to be obviously Airflow. So Airflow, from Airflow, we're going to import DAG. This is going to be a default one that we're going to need because obviously we need to type our DAG from docker.types. We're going to import mount. This is going to come in handy for us later. Because we're orchestrating Docker services or Docker containers, you need some specific Docker types, and then we're also going to need a specific Docker operator that comes from Airflow in order to actually orchestrate them. The next thing we're going to need is going to be from airflow.operators.python_operator. We're going to import the Python operator. So this is going to be very, very crucial because our ELT script is a Python script. We need the Python operator in order to actually add that in there. Okay. So we're actually going to copy and paste this down here as well, because in the same operators package, we're going to need the bash operator. We're going to change this to bash operator. So That way we can actually interact with the bash here and do a couple commands there. The last one we're going to do is going to be from airflow. Actually, should be copying this again. So from there, we're going to say docker underscore, or I think it's just docker here. Yeah, just docker, and then the docker operator. Cool. So these are all the packages. Oh, actually, we're going to need one more subprocess. Silly me. Okay, so those are going to be all the packages that we need here. Now let's go into some default arguments here. So we're going to say default underscore args. This is just a couple things. So the owner of this whole project here is going to be airflow. The next one is going to be depends on past. So do we want this to depend underscore on underscore past? We're going to say false on this, so it doesn't. Email on failure. These are just some things that are built into Airflow, and we are setting some default values here, default arguments. We're gonna say false, and then on email underscore on underscore retry. I think these should be curly brackets, not square brackets. If I screwed up on that one. Cool. All right, now we're gonna write a function here. Define run underscore ELT underscore scripts. So this is going to be a function we use in order to actually run the script. Now we're gonna need the script path, obviously. Script underscore path. We're gonna set this variable here, and this is going to be pointed to where we've set it inside of the Docker container. So if you remember correctly, this path right here. So we have opt airflow /ELT. So we need to point to that and not where it's pointed to locally for us. So we're going to say /opt /airflow/ELT underscore script .py. So now we're pointed directly to the path of the ELT script from within the Docker container. So what we can do now is we're going to say result equals subprocess.run. And this is going to be, you know, we've had this command inside of actual batch script itself. So we're going to say Python, we're going to run Python, and then we're going to use this pointed to the script path. Now, after this, we're going to add a comma, and we're going to say capture output equals true. So we want to capture the output there, and the text equals true. Okay. Now after that, we're going to add a control structure here. So if result.return code doesn't equal 0, that means we failed something, so we need to raise an exception. And in that, we're going to say script failed with error, and then we're going, okay, and then else we print the result output. Cool. Now let's actually put this into a DAG. So we're going to say DAG equals, and then point it to the DAG object that we just imported, add a parentheses, and this is where we add in all the information. So the first one is going to be the name. So we're going to name it ELT underscore and underscore DBT. So that's going to be the name of our DAG. Now, the default arguments, this is where it comes into play here. So we're going to say default arguments equals the default arguments that we've specified. The description of this DAG is going to be an ELT workflow with DBT. Rhyming accidentally. The start date, start underscore date, is going to be date time. So that's where we're going to use date time here. And we're going to say 2023. The time of this recording is currently October 28th. So that's going to be our start time there. Catch up is going to be another one. Catch up equals false. We're not going to catch up. All right. Oh, I didn't close it. I'm done. So now we're going to go into actually writing out the tasks. So you can name a task whatever you want. The first thing I'm going to do, or the easiest way to do it for me, is going to say T1 for task 1. That's just the way I like to do it. And we're going to use the Python operator because the first task we want is the ELT script. And because it is a Python script, we need the Python operator. Now let's do the same thing where we initiated the DAG here, where we're going to add a parentheses. The task ID is going to be task underscore ID. We're going to tag this over and, you know, label this as run underscore ELT underscore script so that we can identify this properly. We're going to say Python callable equals the run ELT script function that we just created, and then the DAG is going to equal DAG. Okay, so very, very simple. We've given it an identifier. We've added the Python function here in order for us to actually run the ELT script, and then we've attached it to the DAG that we've created. All right. The next one is going to be task 2, which is going to be DBT. And obviously for DBT, we've added the Docker operator. So let's go ahead and add all the necessary information for the Docker operator. The same thing is going to be here. So task underscore ID, right? We're going to name this. The same one is going to be DBT underscore run. Very simple there. After task ID, we're going to need to attach an image to it. And so we do have a DBT container, but we're actually going to remove it and replace it with this. So we're going to do the same information that we had in the Docker or the DBT container. So we're going to say ghcr.io/dbt-labs/dbt-postgres for the Postgres adapter, and then point it directly to 1.4.7. All right. And the command we're going to run is going to be the exact same. So you can see kind of like the similarities here. So we're going to say that, we're going to point it to the profiles directory, and the profiles directory is going to be /root. The project directory is going to be /dbt, and then that should be it. The next one for this one is auto remove. So auto remove is, do we want to automatically remove the container once it's finished? And we're going to say true, because we don't want it open all the time. So docker underscore URL is going to be the next one. And this we're going to be pointing directly to the socket that we opened. So Unix //var/run/docker.socket. Right? It can identify where the Docker container is. Now the network mode, we're going to label as bridge. And if you remember, the Docker or the network driver for the Docker network that we had was a bridge. So that is going to be our mode here. And then mounts. So mounts is going to be where we imported the type of mount. This is where we're actually doing the same thing that we see here in the DBT service, where we've mounted these two volumes here. And we want to mount them because we're actually doing exactly what we're doing here, but instead we're doing it inside of Airflow. We're creating this Docker container from scratch using the same information, but that way Airflow has sight of, okay, well, this is exactly what I'm orchestrating. Let me go ahead and create this and then run it. So the first thing we're going to do is say mount, and then inside of that is going to be source. The source of this is going to be the local path of my actual custom Postgres. So I'm going to say users / my name is Justin Chau /development, and this is going to be separate and very different depending on what you're doing here. So the inside of development is just the ELT folder, and then we're going to go into custom underscore Postgres, which is where my source is. Now after this, we're going to say target equals / in single quotes /dbt. Well, that's essentially mapping the source to the /dbt folder. And we're going to say type equals bind. Okay. Now what we're going to do is we're going to copy this. Now we're going to add a comma here. Now this is going to be shorter here, so I can get rid of pretty much everything here. And then we're going to say .dbt because this is our profile. And then instead of target being /dbt, we want this to be root, and the type is going to remain bind. The last thing we need after the mounts is going to tag it to the DAG. So DAG. And there we go. That's pretty much writing both of our tasks. The last thing we need to do here is create the order in which we want it to run. And so at the very bottom here, we're going to say T1, 2 greater than signs, and then T2. So this means that T1 takes priority over T2, and that's the order that we want it to run in. Okay, so let's go ahead and make sure to save this. It looks like we have, that's fine. We don't have to worry about this. So that is pretty much writing our DAG here. Let's go over it one more time. We've created some default arguments here that Airflow needs inside of the DAG. We've created our Python function in order to correctly identify where the script is, and then we're going to go ahead and run it with some error checks here. We've created the actual DAG itself and named it with the default arguments, a description, and then the start time. We've created the first task here using the Python operator, given it an identifier, pointed the function we created to it, so that's what we know to run. And then we've attached it to the DAG we created. And then this is the second operator, or the second task here, using the Docker operator and essentially creating DBT in a new container, and then running and mounting everything we need to correctly have, the DBT project run on top of the destination once the first task has run. And then we've created the order of operations here in which we want it to run. So hopefully this all makes sense. In this next one, we're going to go ahead and run it and show you what the web server looks like, and then make sure that the DAG actually works. So let's get into that. Okay, so we have our DAG. Now, the one thing to note is that we are actually running the script here and then creating a new Docker container here for dbt. So we can actually go back into our Docker compose file, and we're going to comment out the dbt as well as the ELT script containers because we do not need to create them anymore. Because we have Airflow doing it, we don't need to have them anymore. So let's go ahead and comment those out. And what we're actually going to do is we're going to do Docker compose up and run all these containers. So I forgot to do one thing. So remove the port section, and then the command should be scheduler, not web server. That's my bad. So let's do Docker compose up again. Ports must exist. There we go. Okay, it's just some weird issue there. So this is Airflow initializing everything. Everything seems to be going into plan here. And so now what we can do, exit with code 0, we should see the scheduler and the web server pop up in just a second here. Oh, you know what? Okay, so now that we have everything going, let's go ahead and create all of our Docker compose files. But the first thing we have to do is actually run the init Airflow container first, because that's very important. So we're going to say Docker compose up init-airflow, and we're going to actually say -d in order to do that first. So what that's going to do is going to start the Postgres, and it's going to start the initialize Airflow containers first. And if we go to Docker desktop here, you can see that they're already running. We actually need those to be running first before we enable anything else, because without those, the web server and the scheduler will not work. So now what we can do is we're going to say Docker compose up, and that's going to create the rest of the Docker containers that we have. And so let's go ahead and wait for that. Now we can see that the web server is now open. So what I'm going to do here is going to open a new window, and then we're going to go to localhost. And remember, we said 8080. So if we go to localhost 8080, we are now in the Airflow UI. So Airflow password was the username and password that we enabled here. We're going to say no here, no. But you can see we have an issue. Opt airflow dags elt_dag.py, the broken dag. So that's fine. I think what we probably forgot to do was install the Python operators. So let's go ahead and debug this really quickly. Ain't nothing like a little bit of problem, right? So let's just make sure airflow.oper.python oh, so this should be an operator, not operators. Now let's go ahead and go back and kill all of these again. So Docker compose down D. We're gonna say the same thing. So we're gonna say Docker compose Airflow D. We'll let that run for a second, and then Docker compose up. Okay, let's go back to our web server here. Should load up in just a second. Go Airflow password in. I may have tried a little too soon. There we go. We're still running into an error here. Docker's the operator. I think I probably did this. Let's look at the Docker file here. Pip install Apache -airflow docker. Okay, so I found the issue. It was from the actual package here, so I wasn't doing it properly. On the Docker file here, Apache Airflow providers Docker. So this should actually be airflow.providers.docker and then .operators.docker. So that should be the import name. That's why we were getting the issue here. So we're gonna say Docker compose down D. Do the same thing here, and then Airflow. Wait a couple seconds, then Docker compose up in a second. Now, hopefully, this should fix the issue because I had another just like simple typo. So if we go back now, refresh Airflow password, still the same issue. Oh, I had it twice. It's another typo. Okay, so this shouldn't be operators. This should be providers. Okay, compose down. I'm a V. Docker. Initialize it again. Docker compose up again. Just some simple typos that are screwing it all up. There we go. Now that I haven't typoed anything, you can see that we have the ELT and DBT DAG here. We have the owner being Airflow. We have all the runs. So you have failed, running, success queued. You have a schedule, your last run, next run, which we pointed out would be today. But we're going to go ahead and manually run this. So what we're going to do is we're actually going to trigger the DAG. And what we're going to see here is we're going to see it run. So we see one is still queued. So we have one successful. And I believe we should be waiting for one more to go. I believe we're still waiting for one more to go. Yeah, okay. So we see one has failed. Now let's go ahead and check why. So the DBT one failed. DBT was not running the state. So we can check the logs here. Now remember that we created that that Postgres service for the Airflow. And so that is because of this. So we needed the actual Postgres database for this reason. So we can actually get some logs here. If you didn't have it, we wouldn't get any logs here. So it's actually erroring out because custom Postgres.mySecondDBT model depends on a node name myFirstDBT model, which was not found, which is interesting because this is not what we had in mind here. Very interesting. So it looks like the script worked, but the DBT section did not. So we're gonna have to take a look at why, and it has to be something in here, right? So a DBT run profiles directory is going to be /root, project directory is going to be /dbt. If we check the Docker desktop, we go into web server, go into files here, and then I believe so root should contain our dbt folder with the profiles.yaml folder, and we can actually see that custom_Postgres has exactly the information we're looking for. So that's root. That is fine. The other one that we should have, Airflow DAG. No, not Airflow. Where did we put the actual? Put in /dbt. So let's go back. This should be in a dbt, but it is not. /opt/dbt. And I believe our models should be in here. Okay. So I think we're pointing it to the wrong area here. So /opt/dbt. Let's go ahead and see if that changed everything, because we didn't create the DBT section there. So let's go ahead and restart this. So we're gonna say Airflow. Wait a second. Okay, let's go back to the UI password. Okay, this is still going. Let's go ahead and trigger it. Okay, I think we're still waiting on one. One's running right now, which is a good thing. Let's hope it doesn't fail. Fails. Now let's go ahead and check the logs here. Here, invalid project directory, not a DB project YAML. Okay, so that's a better sign, which means that we just need to change this now. So /opt/db. Now I believe that when we run this, it should work. Let's go ahead and kill this. Same thing. That goes up. Should be good. Gonna reset. Go ahead and run it. So it looks like the ELT one ran successfully, and then we're just gonna wait for the second one to pass. Hopefully it does. And it's still failing. Why is it still pointing to the other model? I don't know how this happened, but inside of the example folder, there was a mySecondDBT model SQL file that was throwing the error, so I just deleted it. So now let's try and see if, I don't know how that got in there. I don't even remember if I deleted it or not, but obviously while we were testing it manually, it wasn't throwing an error, but now Airflow decides to throw the error. So let's go ahead and see if that's going to fix the issue. I'm pretty sure it will. Very just like, didn't even think about it kind of thing. But again, like I'm leaving all these mistakes in there, not because it's like, obviously it doesn't look that great, but I do believe that these errors are just a part of engineering in general. And so I think it's good to put some light on it and just, you know, not every course or not every lesson is going to be fully fledged. I think it's better to just leave that stuff in there because, you know, we all go through mistakes. Stuff like this happens where it just, you know, there was one file that was throwing everything off or something like that. Now let's go ahead and see if I can actually get in here. So I can refresh and I'm in. So let me go ahead and hit start on the DAG and let's see what we get here. So it looks like our batch script worked. Now we're just waiting for Airflow. Let's hope for a number 2 on the green. I think we're still running. Cool. That was it. That was literally it. So now you can see we have 2 on the success part. So we have our DBT and our ELT script that ran successfully. So what we can do now is we can go into our destination Postgres and do the destination _db. and we're going to say /dt, and you can see all the models and everything that we ran are now inside of the destination. And to prove that, I can say select all from let's say specific movie again, and you can see that the inception selection is still there. I can say select all from users, and everything should be in there. So that is successfully adding Airflow with some minor hiccups, but obviously you can see here that our Python operator and our Docker operator are in play here and working. It does take a little bit of work to make sure that everything is moving, because yes, there is a lot of moving parts here. But in this next section with the ELT script, we're making it a lot easier because we're removing the need for the ELT script. We're actually adding in another open source tool that I happen to work for called Airbyte to be able to add more integrations and more data sources, more destinations with ease. So let's look at how that would work with orchestration and everything like that all put together now. All right, so for this next and final section, like I mentioned, we're going to be implementing an open source data integration tool called Airbyte, which I just so happen to work for. Airbyte, we are pretty much a data movement platform, like I just said. So you have a bunch of sources, like we have our source database and we have our destination database, both in Postgres. Now, imagine you have a couple other sources that aren't just Postgres, but you also have places like Salesforce or LinkedIn, Facebook marketing, places like that where you need data to come out of and then move them into, your destination Postgres database, or you may have some cloud data warehouses, things like that. Airbyte is the platform to easily sync all of them together without having to manage any of these manual scripts like the one we just made. Use a dump file to go from Postgres to Postgres. It would be much more complicated if we were doing that from a different source to a different destination. And so I'm going to show you how easy it is to get Airbyte into your project, and it's open source, like I said, and utilizes Docker, so it's pretty easy to hook up to the rest of our application and then get Airflow hooked up as well. So let's go ahead and do that. So I am on the Airbyte repo right now, which you can just go on GitHub, and all we're going to do pretty simply is just copy this. What we're going to do is we're going to go back into our terminal here. We're going to stop all of the Docker containers. And then what we're going to do is git clone, and then we're going to clone Airbyte into our repo here. So that's going to take a little bit. The big open source package. And then if you wanted to read the README on how to get started and things like that, all of it is down here. But you can see that literally, like, you can use this project for free. And that's the beauty of open source, right? So now if we hit ls, you can see we've created an Airbyte directory here. And if we open our project here on VS Code, you can see that Airbyte is now successfully inside of the file directory along with everything else. So now let's hook up everything together to make sure that it works in harmony. So before we run anything with Airbyte, we actually got to set up a couple things. So we do not need to touch this Docker Compose file anymore. That is completely all set and ready to go. If we go into this Docker file, you can see that obviously we've installed the Docker provider. We're actually going to install the Airbyte provider as well as a couple other things. Yes, like I mentioned, that there are a couple other integrations with Airflow, and Airbyte is one of them. With open source, it's a little different, but we do use the HTTP provider as well as the Airbyte provider. So we're going to change this command up a little bit. So everything's going to stay the same, but when we run pip install the provider's Docker, we're going to add a little slash here. We're going to say and pip install Apache Airflow providers, and then we're going to say HTTP. We're going to add another backslash here, and we're going to add another and then this is going to be pip install Apache Airflow providers Airbyte. So now we're installing 3 different packages that we need. I mean, yes, we do need the Docker one still. But so yes, we're going to be using Airflow for Docker, HTTP, and Airbyte work synonymously together. HTTP provider is a dependency for the Airbyte provider. So now we're going to save that. I'm actually going to change up this start.sh file. So it's going to make it a little bit easier to run the whole project all together. We don't have to keep waiting for the init Airflow to start, and then we can kind of structure the way that all these Docker containers are running with this bash script. So let me go ahead and do that right now. Okay, so we're going to actually delete all this stuff that's in here right now. The first thing that we want to do is we want to do Docker compose up, and then we want to do init Airflow. Now that's going to obviously do the initialization of Airflow. After that, we're going to wait 5 seconds. So we're gonna sleep the command for 5 seconds. And then next we're gonna say docker compose up -d to run it in the background. Because if we don't run it in the background, we can't really continue to see Airbyte come through. So after that, we're gonna sleep for another 5 seconds. After that, we're gonna change directories into the Airbyte directory, because if we see it here, you can, well, you won't see it now, but there is a docker compose file that needs to be downloaded here. And that's exactly what we're gonna do. So we're gonna cd into Airbyte, and we're gonna do a little check here, because the way that we run it is there's a run platform shell script that we need to run with Airbyte. And that is the initialization where it downloads all the correct files that we need to in order to spin up all the Docker containers. So we're gonna say if, and then we're gonna look for the file here. So we're gonna say -f, and then we're looking for docker compose.yaml. That's the file we're looking for. If that exists, then we're going to run docker compose up -d. If it doesn't exist, we're gonna run /run -ab platform.sh, and then we're gonna finish. Okay, so very simple script here. We're also going to create another one that's going to say stop.sh. So this one is going to say docker compose down -v, and then we're going to, I think we're going to sleep for 5 seconds. We're going to cd into Airbyte, and then do docker compose down. So that is going to be the start and stop for this, to make this easier to run every single container. So now what we're going to do, we're going to go into our DAG and then change up everything, because we no longer need this ELT script. We're obviously going to still need the Docker operator, but the Python operator, we don't need it anymore since we're going to be using Airbyte to do it. So let's go ahead and hook that up right now. All right. So like I said, we actually didn't end up using the bash operator, and we don't need the Python operator anymore. So we can remove this. Let's go ahead and remove the time delta as well, because we do not need that right now. So what we're going to do is also remove this function here, and then this is what we're going to start doing our actually I'm going to leave this for now. So right here above the default args, we're going to create a con_id variable, and this is going to be a string. So this will make sense. So a connection ID is what this stands for. Within Airbyte, we have a connection ID and a workspace ID, and those are just identifiers for your specific instance of Airbyte, let's say. But more specifically, if we're looking at the source and the destination that we currently have, both of the Postgres databases, connecting those together obviously create a connection. And for Airbyte, when we connect the two, we have a connector, and that connector has that connection ID. So that's exactly what we're going to use this variable for, is to grab that and then input it here into the DAG to make sure that we're orchestrating the correct connector right now. And so here, what we're going to do is we're actually going to come back up here. We're going to say from Airflow. The first thing we're actually going to do is from utils and dates. So we're going to use the dates util from Airflow. We're going to import days_ago. Under that, we're going to say from Airflow .providers .airbyte .operators .airbyte. We're going to import the Airbyte trigger sync operator. So this is going to be the module that we're using to trigger syncs on the connection that we create from within Airbyte. Now we're going to replace T1 with this operator here. Let's go ahead and replace it. And now the first thing we're going to do is change the task ID. So this is, oh, whoops, I replaced the wrong one. This is the Python operator we're trying to replace. So the first thing we're going to replace is the task ID. So this one is going to be the Airbyte _Postgres task ID. And we no longer have a Python callable here. But the first thing we're going to do is Airbyte _con_id, which is an argument that we need, which obviously we've provided, which is going to be Airbyte. So this will make more sense once we're inside of Webflow, but we need to make a connection inside Airflow, and we're going to name that Airbyte. So we're going to add that. The connection ID is what we provided. So this will point to the con ID variable that we had. Right? I'll make sure that I add my commas here. Underneath that is asynchronous. So if we wanted to asynchronously do jobs, asynchronous, I think is how I spelled it. Wait, did I spell that right? Asynchronous. False. So this is not going to be asynchronous. We would have to add another operator, but we're not doing any jobs asynchronously. We're only triggering one job. So we're going to leave it at that. We're going to leave the timeout to 3600. We're going to say wait _seconds. We're going to wait 3 seconds. And then the DAG, obviously, we're putting back into DAG. So you can see pretty simple in terms of what it's accepting here. The main thing here to note is going to be these two properties right here. So the Airbyte con ID which we're going to find within Airflow. And then the connection ID is going to be what's important to us here. So we're actually going to save that, and nothing else changes. So we've successfully put an Airbyte within the DAG. The one thing we need to do here is we do need to add our connection ID, which we have not gotten yet. There is a little bit of a trick here that we're going to have to do. It's kind of inefficient, but for the sake of this project, we're going to have to do it. So let me show you what that is. We're going to have to make another bash script potentially, but it should all be okay. This is what happens when you kind of have to work with multiple different Docker containers, since Airbyte is working in its own. So let's go ahead and do that right now. I'm actually going to create another bash script here. This one's going to be elt.sh, and this one is going to be exactly what we did before, where it's just docker compose up init -airflow, and then we're going to sleep for 5, and then we're going to docker compose up -d. So the reason for this is that Airbyte has its own set of Docker containers that are running to make sure that everything is working. And then we have our own ELT containers that we've already been working with, and we can close those separately. Now, in order for this to work, we need to grab the connection ID that we make from within Airbyte. And in order to create the connection, we need to obviously hook up the source and the destination together, which we're going to do next. But then when we have the connection ID, we can't necessarily save the connection ID into the DAG and then, load it up. We're going to have to kill the container so that the new connector ID propagates, but Airbyte will still be active. So we're just going to go ahead and kind of go through that process. But then at the end, we'll see that Airflow is able to read everything that we've done, and then we can orchestrate both Airbyte, that's replacing our ELT script, and then using dbt to write on top of the destination databases that we have currently. So let's go ahead and run Airbyte right now, and then we'll get going into hooking up both of the source and destinations to create our first connector. All right, so now we're in the UI, and then now all we got to do is just put in our information here. You can choose this if you want, but I'm going to say get started. And then now we're in the Airbyte UI, and let me walk you through really quickly. It's very simple. So we have connections. So if you have all your sources and destinations and they're connected together, this would be your connections. If we go to sources, you can see we have a bunch of different sources, both certified as well as community, and the same thing on the destination side. So the one thing we're going to do is we're actually going to go for Postgres here. You can see it's pretty simple, and it's just simply logging in to your instances here or our databases. So I'm actually going to name this source Postgres. And then for the host here, we're going to say host.docker.internal. And for the port, I believe port 5433 is the name, or is the port number. And then for the database name is going to be source_db. Now for the username was just Postgres, and for the password was just secret. Okay. Now, no SSL modes, no SSH tunnels needed. For this sake, I'm going to be using detect changes with the xmin system column. And then, if you have any JDBC URL parameters here, you can absolutely add that. Let me go ahead and hit setup source here. And then it should just essentially make a call to the Postgres database there through the API. And we're off to the races. It should just connect properly if everything is correct. And if I look on Docker, we should have the containers open. So that is correct. Cool. All the test connections have passed. So then it spits us over to create a connection. And we're actually going to add a destination now, which is going to be also Postgres. Now it's going to be the same thing. We're going to name this destination Postgres. Host.docker.internal. The port here is going to be 5434. DB name is going to be destination_db. Default schema. We're going to name the user Postgres. And then it's kind of hidden right now, but in the optional fields, we're going to say secret as the password because we do need that. And then we're going to go ahead and hit setup destination. And cool. All test connections have passed. And what you can see up here is that we have, the connection name. So you have source Postgres to destination Postgres. Replication frequency, there is an orchestrator from within Airbyte, but we want to switch this over to manual because we are orchestrating this with Airflow. If we wanted to just have this work on its own, we can absolutely do that. If we wanted to add a cron job, you can absolutely do that as well from within here. But for our sake, we're going to use manual. There's a namespace. There's the stream prefix to identify streams a little easier. And here is all the tables coming in from our source database. Now, what I'm going to do here is I'm going to check all of these because I want all of these streams or all of these tables to come with. And now from here, we can choose a sync mode. So do we want to fully refresh every single time? Do we want to incremental, which we recommend only the changes because it does support CDC? Do we only want to sync the changes from the database over to the destination, depending on the transactions? In our case, we're going to do full refresh overwrite for all of them, so we can do some testing here. But yes, incremental sync is probably the way to go here. We do offer normalized tabular data in this, so we do some normalization on top of the data, and that is totally fine. So I'm going to go ahead and set up this connection here, and there we go. Once this is all set up, we can see here at the top, we have a couple IDs that are very important to us. So the first one is going to be the workspaces ID. The next one is going to be the connections ID. We want this connections ID. So what we're going to do is copy this, head over into our DAG and paste this into the connection ID. Now we're going to save this, but remember what I said when we when we launch Airflow and all of these containers right here, they're in separate instances, right? And so the change I just made has not propagated. And so we're not going to be able to stop or to start the DAG right now. So what we're going to do is we're actually going to kill the ELT section first and then leave Airbyte open, restart this. We should be able to then start the sync using Airflow. So what I'm going to do now is Docker compose we have that ELT script. So what I'm going to do is I have to add chmod plus x./elt.sh. And now I can say elt.sh, and that should run the init first, and then that should run the rest of the Docker containers we need on the ELT side. So the init is done, and we can see it down here, and then it should follow up with all of that. So there we go. Everything should be initialized. Now, what we have to do is obviously Airbyte is still running. Now let's go in and do localhost port 8080. So that's going to let us sign into our instance here. We're having an issue with the DAG. I think it's the provider here. Yep. Okay. So I had this issue with this before. Airflow.providers.airbyte.operators.airbyte. Let me double check to make sure that is the correct installation of it. So what we're probably gonna need to do is, for some reason, this doesn't fully work here. User Airflow. Yeah, because let me double check this. Oh, I forgot to do that. Okay, so the one thing we do actually need to do is we need to remove this user tag here because we want the user to switch every single time. So it's a weird thing where you have to be the Airflow user before to install the actual correct operator and then switch back to the root in order to run the DAG. So that's what we're going to do. We're going to do docker compose down -b and then run our ELT script again after we remove that. So let's go ahead and run it. Should be good. So then it'll go down and read the user Airflow first, run this command to install all the correct operators, and then we'll have back to the user root once they're installed, that we can actually run the DAG. Okay, so that should be good. Let me go ahead and wait for it to run here. There we go. Still having an error here. All right, so I got it working. And this is just a note. There is some weird issues kind of with Docker, but so if you ever run into issues like that, you want to go into the images section. So I had to look for the ELT web server and scheduler because we had built those images already, and it doesn't propagate with these new commands here. And so when I when I deleted the images and reran it, it actually went through and installed the correct operator. So now if we go back to the web UI, you can see that the DAG is now in there. So we did everything correctly. It was just a matter of deleting the images on Docker first. And so now what we're going to do is before we even run it, we need to go up into connections and then hit this plus sign right here. And now what we can see is we have a connection type of Airbyte, but that's not exactly what we're going to be using. So if you remember this connection ID, if we go back to the code of the DAG, you can see we had a connection ID of Airbyte. So what we're going to do is we're going to say Airbyte. We're going to go down into HTTP, and then for the host is going to be host.docker.internal. We don't need to provide login password, but for the UI, we're actually going to point it to 8001 because that's going to be where we can access the actual UI and everything. So we're gonna hit save. And so now we have this Airbyte section. If we go back to DAGs, let's go ahead and trigger this. And so we triggered it. If we go back to the Airbyte connections, we should be able to refresh and hopefully see that a stream is going to start here eventually. Okay, so it failed instantly. Okay, so it looks like it errored because let's actually go back to the connections here. We actually may need to do a login password. So this is host.docker.internal 8001. Let's add Airbyte and password, because this is a default thing that's needed, or login that's needed for us on our side for security reasons. And obviously that can change. Let me go ahead and rerun this again. And that should give us permissions to run the sync. There we go. So now you can see that we have a sync running. So we've been able to trigger the actual sync now using Airflow, and that should just work. So if we go back to statuses here, we should be able to watch it go. And then once that's loaded into the destination, then the DBT container will spin up, and then we will have all of our models written onto the destination side, but data was moved from Airbyte. So let's go ahead and wait for that to load here. But if we go back to the DAGs, we can see that it's all working now. We were able to successfully connect to Airbyte, and it's not going to succeed until this is completely done. There we go. So sync has succeeded. You can see that we have 113 records extracted. If we go back to Airflow, we should be able to see that it will succeed, and then it's going to run DBT. There we go. So there's the first success, and then now we're waiting for DBT to run. And then once DBT has run, we're going to go ahead and check. So DBT just successfully ran. Go back into our terminal, and then go back into our destination database. So C destination underscore DB. Let's go ahead and do a /DT, and then you could see, so now we have some extra stuff. So you could see Airbyte actually wrote some raw data into the database, but it has come with all of the other tables here. Notice how specific movie and film ratings isn't here. So you can see that DBT actually ran. We only have the tables coming from the source database. And now if we do select all from specific underscore movie, that's going to show the actual inception, you know, all that stuff along with some Airbyte metadata. So you could see that has actually successfully worked. We have Airbyte being orchestrated by Airflow and DBT now being orchestrated by Airflow, all within this simple project. And that right there is the full project completed. Hopefully that gave you a pretty high level understanding and example of how you could successfully create a data pipeline from scratch, but then ultimately lead that into a fully fledged open source data pipeline where you're sending data from a Postgres database using a tool like Airbyte to connect it to a destination database where you need the data to go to. And then from there, you're orchestrating it with Airflow, writing custom models on top of it with DBT to then use for other sort of data analysis or things like that. Ultimately, the destination could be anything where it ends up in a CRM or some sort of tool like Metabase or Looker for other open source options there. But essentially, this is kind of like my version of a storytelling where you can see how a data pipeline can evolve, how complicated it can be at the very beginning, but then how simple it can be at the very end when you start using some of the tools in the modern data stack where, you know, you have tools like Airbyte and Airflow and many other tools where you can bring into the stack and just make it a lot easier as a data engineer. Now, the opportunities here are endless, and this can hopefully open some doors to you to test some things and also play around with other things to become a data engineer eventually. But please let us know how we did. Please let me know if you have any questions or if you learned anything new here. Please let me know down in the comments or anything like that. But I hope you all enjoyed this course, and thank you so much for watching.